Okay, we are recording. And this is ELC 128 PLC class. And this is June the 4th, 2020. If you're watching recording. And I'll go ahead and announce updates as far as things I've added in Moodle today. And for folks that are kind of behind, the assignments going all the way back to the beginning that need to be done, and you can go back and check whether you've done these or not, or if you don't know, just check in Moodle in your grade book for your grades, and you'll see what you've done and what you haven't done. But for lab number 1, that's the basic logic functions, and you would do that lab in the written portion has questions, so you want to do the questions and submit that, and then you're going to write those 7 different types of logic in the emulator, and let me see them running the emulator, or email me the copy. So if you're one of the people that cannot join at this time and you got other things going on, at least create it and then email me the copy so I can give a grade. Because everybody, if you don't turn it in, period, you get a 0 for it. So, but everybody's got time to catch up. So for your basic logic functions, you have the written part with the questions just in Moodle, and then also the emulator part that you let me see it run or send me the emulator program, and then the actual PLC program that's going to run on the Compact Logix. And for that one, I put in Moodle the PLC I/O schematic showing the wiring and the addresses that you'll use whenever you take your basic logic functions and adapt it with real I/O addresses, and then you can let me see what you have, or send it to me through email, and we will run it on the actual PLC. So there's 3 parts to your first lab: written, emulator, and then real PLC. And then the next one is on the Sump Pump, and it has a guide that I put in Moodle that you can see. You'll see the actual lab that would have been done on campus if you were in our shop in the classroom in there. You'll see the actual lab you would do in person. So you've got that. You can download all these things that I'm putting in Moodle. Download those if you want to print them on paper. You can. I like to have paper copies of things down the road to go back and refer to, instead of having all of it just on a thumb drive that could go bad. Because thumb drives, I've had a couple of them to go bad over the years, and they're not really guaranteed to last forever. They got an average lifespan of about 10 or 12 years, kind of maximum. And I've seen 2 fail in a much shorter time than that. But on the Sump Pump, you will do an emulator version of it, let me see it run, or email me a copy. And then also you'll do it with real I/O that I posted last night. So I put your guide in there showing the Sump Pump PLC I/O schematic, showing the wiring and the addresses. That includes the new 3-position switch that we haven't worked with, and also the float switch that I have right here, the actual real float switch that you're going to have, that I have the real thing wired in here that you can, hold on, let's get the camera over. Yeah. There goes the real float switch like you would have in a tank. And that's what you're going to wire in there, or program in rather. I've already got it wired. So anyway, so that's it. And for those of you that are at the head of the class that are just going at it like gangbusters and doing real good, I have put, and let me back up, chapter 1 in the book, chapter 1 in our textbook. And for those of you that don't have the textbook, which this is it right here, if you don't have it, I'm putting copies of the chapters. I photocopied chapters. I'm putting them in Moodle. So download it, save it, print it if you want to. At least download it and save it on your computer so you've got it to keep. And you can put them on a thumb drive. Chapter 1, there's a worksheet. And if you haven't done it, then you need to get that worksheet, read that chapter, and do the worksheet, submit that. Again, all of this stuff is required, even though we're online. And also today I added chapter 2. Chapter 2, there's a book copy of just that chapter, in Moodle. You can download that PDF, save it, print it, whatever you want to do. Just keep it. Make sure you got it at least downloaded. And I put a worksheet in Moodle today for Chapter 2, and it's on understanding the I/O section. So anyway, and it's a very big chapter, but every page I photocopied and I scanned the whole thing, and it's in Moodle that you can get it very easily, and so that's a thing that you can work on the weekend. You can go ahead and be working on reading Chapter 2 and doing the worksheet, completing all that stuff, and if you have questions, you can contact me in between classes. Will be fine, and I'll be glad to help you. And I also put another lab in there for people, say like Kenneth, this already sent me the PLC version for Sump Pump. He's already got IO addresses in that one. And so people like him that have got the time to do it and that are going ahead like this, I put another lab in Moodle. It's in section 2, and it's on latch and unlatch instructions, which is the next lab after the Sump Pump. So Ken, if you can, once we test your Sump Pump on the real PLC tonight, you could actually go ahead and just start working on that latch and unlatch lab. I put a lab guide in Moodle. You read through the lab guide, and it explains what these instructions are and when are they used and when are they not used, because you can't use latch instructions for everything because there's a safety issue with that. But you read that lab guide, and then you will adapt that lab that it's shown in there, adapt it to the emulator. Once you write it in the emulator, let me see it run in the emulator. And then I haven't posted the IO addresses for that one, but you can go ahead and there'll be a second push button. I'll have to give you another address for the second push button for unlatch on that when you get to it. So
sounds good to me.
Yeah, so I'm gonna stay ahead of things enough to where there'll be extra stuff on in Moodle for you to be doing. While if you're just kind of waiting and there's 10 more people to get checked, while you're waiting to get checked on something, you can kind of be working on something extra that I put in there if you're up to it. Okay. So anyway, I haven't checked today to see who has done what in Moodle, but the other day the latest thing I have, I'll just give you an example of kind of what I'm looking at here. That's an example of what I'm doing. I'm recording things on paper, but it just shows you where there are things that are missing in here from certain people. And tomorrow is when I'll start catching back up on grading again to record whatever's been submitted since the last time I checked on assignments. So anyway, we're going to get started.
What the hell I did wrong?
What?
I'm trying to figure out what I'm doing wrong here.
Doing wrong on what?
On my Sump Pump. For some reason, I can't get it. I download it, but it won't let me go to RIM.
Okay.
On my virtual.
Do a screenshot and we'll get it figured out.
I know I'm doing something wrong. My brain locked.
It's all right.
Say it happens, huh?
if you knew it all, you wouldn't even need to be in here. You'd be teaching it.
Right. All right, there it is, Durwood.
All right. Go out and look at what you're calling a sump pump motor.
What do you mean?
On your program, look at where you've got sump pump motor.
Right here.
No, go to the output.
Oh.
All the way to the right of the rung.
Are you talking about over here?
Yeah, that. Look at what kind of look at your instruction that you have there.
Well, I wrote that first, then wrote that one. Well, I didn't write this one. I wrote this one first, new tag. Then I did that. Oh, I know what you're talking about now. Oh.
You put a contact, not an output.
Yeah.
You can't put. You created a short circuit.
Yeah, I did, didn't I? That's why it won't work. Okay, what do I got to do to change that?
Close that screen.
Close that screen.
And now go in the center of the contact itself and double click it.
Double click it.
And now where it says XIC, put OTE for output energize.
OTE.
You can put the three letter mnemonic. The mnemonic. Do the drop down. Let me show you something. Do the drop down.
Right.
To look at all the options you have.
Oh, okay, cool.
See, the 3 letters give you the mnemonic. A mnemonic would be an abbreviated, like 3 letters in this case that would represent every instruction that we have. So output energize is OTE. Examine on is XIC for examine if closed. Examine off is XIO, examine if off. So every instruction has got a 3-letter mnemonic, short term, shortcut there that shorthand that we use. So you can make those changes directly like that, and then just hit enter on your keyboard.
I just learned something new. That's pretty cool.
Well, yeah, that's what you're here for.
I like that.
That's good. And now you want to verify it up top.
Now.
No, don't save it yet. No. Go over there and hit your red check mark for verify.
Red check mark.
Great.
So what?
Go above your start button. Go to the right. Now go straight up. Keep going straight up. Keep going. Keep going. Now go to the left. Now, no. You went too far. There's two green check marks.
Oh, okay. I see what you're saying.
Now that says verify routine. Now, that's all you got to do. Hit verify routine.
You only do that when you make changes, right?
You do it whenever you're getting ready to save and download. You can verify, and it'll tell you if you have mistakes or not.
Oh, that's interesting.
Yeah.
Okay, I know you probably showed us that before, but I forgot.
Yeah. But what we've been doing is on your when you go to save it, it's been popping up telling you whether you had mistakes or not anyway. But you need to see that there's a verify check mark that you can do to verify it before you save it, kind of as you go. You know what I mean?
Right.
Yep.
Okay, Mr. Durwood, I got a question.
All right.
So, is this going to be? Are we selecting the emulator controller, or are we doing the actual controller?
Do the emulator. Do the emulator first.
Yeah, that's what I thought. You wanted this first, what didn't you?
Yeah, I want the emulator first. Yeah, that's the whole reason for you getting the emulator is so that on your end, you can really run your program on your end without me involved. And
then check it. Okay.
And check it and make sure that the logic it works and that you can practice doing the download process and toggling bits and doing it as close as you can get to the real thing. And it's a great thing to have the emulator. I mean, I've never had a reason to use one up until this class. They've been out for years. I mean, these things have been available for years, but I've never been to where I particularly needed to have one till now.
Now it's good to go.
Right. So now you can go through and toggle.
So you want to see mine while I'm already up?
Let's see it run by all means. Yeah, let's yeah. Kenneth said he wants the class to go twice as fast as it is. He said twice as fast. So we've got to do something here.
Now, we don't need to turn these on, right?
Not yet.
Because we got to go through these first, right?
Right. And what you can do for actually a more realistic.
Right. Yeah.
Yeah. Right. Now toggle the start button off. Just hit Control T.
Control T. Control.
Yeah, you don't have to do right click.
I don't know why I did that.
Once you highlight the element, you highlight the element and hit Control T. It'll toggle on, and Control T toggles off.
Okay. Now cut the hand switch off, right?
Right. Now you can highlight it and hit Control T. And now now you're disabled from doing it in hand. Now you can highlight that one and Control T.
Now, do we keep the stop switch? The stop button stays lit up, right?
Well,
still.
Say the question.
All right. With us doing it like this. Okay, yeah. Okay, I just answered my own question, basically. I was making sure, do we keep that still on?
Yeah, you don't have to when you go from hand to auto, it's going to disable that first rung anyway. It's going to take power away from the stop button. So you can leave the stop button alone. It's okay.
Okay, that's what I was asking.
To change modes, you don't need to. Hold on, let me get my seat cushion right here. My seat cushion keeps moving around. I'll show you what I bought. You get a kick out of this. This is you need a good laugh. Okay.
I need to get a seat cushion for my car.
Let me just show you. I got lower lumbar trouble. Okay, I'm scheduled to get surgery in November to get lower lumbar fusion. Now check this seat cushion out right here. You see that?
Yeah.
That is one of them you see on TV that's got the I forget what the advertisement called it. Perfect cushion. It's what they called it on TV. So it's a real plush. It's real thick. It's a nice one, man. It's got that cutout there for your tailbone, because your lower back, and when it goes down to your
S1,
what it's called, sacrum, your tailbone.
S1, yeah, S1, because
so down
that's
in
what
there,
I gotta go through.
if you that relief in there on that cushion lets your tailbone float, so it takes some pressure off your lower lumbar, and
yes,
so that's helping. That's helping because I
know what you're about to go through. I got to go for it next year too. But I got to get my L3 all the way to my L5 taken out. And they got to put a metal rod in
really
all the way down to my S1.
Yeah. But this cushion does good as long as but when I move around, it gets out of place, and then that little cutout is like not where it's supposed to be. So I got to reposition.
All right, you good with that, Durwood?
Yes, sir. Yeah. Now toggle your float off.
All right.
Just hit Control T.
I don't know why I keep doing that. It's a habit, I guess.
Yeah. Once you highlight the element, you can hit Control T, and toggle. It's fast toggling like it would be, on a machine.
Yeah.
So you see how when you toggle the float on, your holding contact still comes on with the start button, but yet it doesn't seal in the top circuit because your hand switch is open.
Right.
It's open. And then, by the way, while you're on that, let me show you real quick with the webcam that the switch that we're talking about, what you're simulating there with two different contacts. I'm going to show you what the switch looks like in the back. It has two separate contact blocks on it. I'm going to move the webcam just briefly here. Now, what you see here is, you see this switch up top?
Yes.
Now, it's in the center position, it's off. Now, that's hand, and then off, and then auto. Now, I'm going to flip it around and let you see behind it. So behind it, up in there, you see those two contact blocks?
Yes, sir.
There's one, there's another one. Now, I'm going to flip it over. You're going to see a little green indicator come out when I go to hand. You see that hand there? It went green.
Yes.
And now neither one of them are. Now I'm in off, and now I go to auto, and then it's the one on the right. You see the one on the right changing?
Yep.
So they are literally two separate contact blocks that are run off of that actuator. You see that jumper up top?
Yep.
That's 24 volts going to it. 24 volts is jumping to both contacts equally on the left side, and then it leaves with individual wires, and it goes to your inputs on the PLC.
All right.
So that's why that's why they have to be separate actual contacts, because they really are. And they're two separate inputs that are going to the PLC. They're leaving that. So that's, you notice the other switches, they only have like one contact block on them. See them in there? Mm-hmm. They only have one apiece. But I added one to that one, and then I ran another wire from the new one to the PLC, and then that drawing that I sent y'all is showing that's where, just to show you where the switches are, is you see the PLCs up top there, and then right over there is where the switch box is with that top right switch. And so your start stop are right there, and then your HOA is up here like that.
Okay.
And then your one motor starter you're going to be running is going to be this one right here. That's going to be your motor starter one that has an overload. So that's basically it. And then the float's right here. That's a real float that comes from Butterball from waste treatment. And when it's down, it's actually normally open. And when the water rises, it does that. It actually clicks and closes. So you're going to see that in the PLC program close and open when it floats and then when it goes down like that. So that's a real float switch there. So
yeah.
And also for those of you, I did manage to get home a VFD. I've got a VFD, a PowerFlex. I got a 1/2 horse motor here. So I managed to I found I could run that 1 horse PowerFlex that's a single phase in and 3 phase out. That's the only one in our shop like that. It's on the automation system off of station 3. It takes 120 coming in, regular out the wall, converts it to 233 phase. And I brought home a 3 phase motor here that I'm running right here in this room in my house. And we're going to interface that VFD another night to an analog output right here. That's an analog output module that's on this same PLC. So we're working toward analog in and analog out for sensor going in, analog sensor, and then analog output with a variable voltage leaving that module that will actually modulate the speed like that speed pot does on that drive. But instead of you doing it manually, it's going to be doing it from the PLC will actually modulate the speed based on a sensor input that's coming on analog in, and the analog out is going to actually make that drive continuously adjust speed to some set point. So anyhow, so we got some good stuff. I got a pile of stuff here in this room, man. It's just like this is my parents' room before he passed, and once my dad passed, then my mom moved into another room. She's not really comfortable staying back here, so. But I've got any of you that are interested in PLC in the 500 PLC, I've got one over there, that large one over there. That's a MicroLogic 1500 suitcase trainer from the college. That uses the 500 software. So for Jamie and Eric and Kenneth that were interested in 500, that's a 500 controller over there, laying down on that bed over there. So okay. We'll figure some time out to get on that, but that's not a priority right now. It's
Mr. Durwood, I got probably a dumb question.
No, that ain't dumb. Go ahead. It's the ones that don't get asked is the one that worries me. The ones I don't never hear.
So like for example, the Sump Pump, the schematic thing you sent us, or the dot wiring diagram.
Yep.
Every time I look at it, I am confusing myself, and I don't know why. Like I'm not knowing where I need to put what at when I'm making my programs.
Do a screenshot and let's just watch you do it. Do a screen share.
I had to go back to the thing.
It'll be, believe me, it's gonna be super simple.
All right, so when I'm looking at this, I don't even know where to start. Like, cause like off the last one, I based how I made it based off how you said to make it and how to pair everything up.
Down there where you're pointing now, you're only going to use one output. You're going to use output 1 for the Sump Pump motor starter. There's only one output that you're going to use in this lab. And on the inputs, you use all the inputs that are shown up top. You're only going to use what's needed for this lab. So for your program, you only use the addresses. What the drawing you're showing me right there, that's the actual wiring diagram that I physically wired. That goes into the PLC. Now, once you get into PLC, the addresses that are shown there, the local and the 1 and the I and the data so and so, that's what the reason I sent you this is so you could get the addresses for the real devices in the field there to know what addresses to make for your program elements, you know. So basically what you can do is now flip over to your emulator, well, over to your studio where you're writing your logic at.
I ain't got nothing but the stop button.
Well, you're off to a good start. The question mark is going to be, it's going to be the HOA hand switch.
So how would I know that based off looking at that?
You wouldn't know it off the
diagram.
wiring diagram. You got to go off of the Sump Pump guide that's in Moodle, the guide. That's what's wrong. You haven't seen the guide yet.
Well, how do I get to that? Because
It's in
I
Moodle.
I clicked everything.
Moodle section 1. Do a screen sharing and go back out to Moodle. Let me just see where you're going.
Am I still screen sharing with you?
Yes, sir.
Okay, I just want to make sure.
Yep.
All right, so.
But you want to go back out to your main. There you go. The welcome mat. Now go on down.
So section 1.
Yeah, and it's right next to. It'll say Sump Pump.
It's right here.
It says the guide. You see where it says lab guide? This is the
so
actual. Yeah, that lab guide shows you what. That's the actual paper I would give you at the school if you were at school.
Okay, well that makes it 10 times. Okay, it makes sense now. Okay,
Right.
I get it now.
You,
'Cause I kept on clicking on the wiring diagram for the inputs and outputs.
well, the wiring diagram shows. Listen, what you're seeing there on the screen right now is a hardwired version. If you had no PLC, that's how it's done in motor controls with no PLC. It starts out showing you that's
that makes sense to me right there.
right. Now scroll on down in that guide, and it's going to show you the it'll show you the program logic now right there. That's what you would do at the school, to where it's got everything in there except for the overload relay, which is external. And so that's what you model it after. And see, at school, I would have you to draw it in those X's in. I'd have you to freehand draw the logic and write your addresses in and all. That's the thing you would be doing with a paper copy. Right there, you would actually draw the a symbol for the switches, the push buttons. That's stuff you would be doing at school, but I can't ask you to do anything by hand that way.
Okay, this makes a lot more sense. I thought everybody was over here making these things off of this right here.
No.
The input and output thing. That's how I thought people were making it. I was so confused for the longest time.
No, see, I've given you the input output wiring, and you would have had to do that at school, but I'm just giving you that.
Okay, I got you. Okay, it makes complete sense now.
That's what I thought. Yeah, you just that's the missing piece in the puzzle for you.
Yeah, okay.
So you're welcome. Every lab that we do now, listen, you look for that on every lab. Every lab is going to have a guide. And what the guide is this. The guide is the paper copy that I would give you on campus that explains the lab, that shows you what a hardwired version would be, shows you the PLC version of it. And all of that stuff is wrapped up in that guide. So you need to be saving them guides to your computer. And if you like I am, I like to have a paper copy of everything. I'm kind of that way. I'm old school and new school. I'm always going to be both, you know. And then, you know, if your computer glips out, you still got paper copies of everything. So it's just a matter of the ink is expensive. The printers are cheap, but the ink is like a fortune keeping ink in them. But it's worth it. So,
all right. Thank you, Mr. Durwood.
You're welcome. You're welcome. Okay. Okay. So Eric completed his Sump Pump emulator. So I'm gonna go ahead and give you a grade for that, Eric, and then we'll see who else has something that they're prepared to show. Let's see. Right. So I got you a 100 down for that. And let me check the roll here. Let me write down who's in now. Let's see. Let's see. This is the 4th, and we've got Dylan Ivy. Got Benjamin. How you doing, Benjamin?
I'm doing good. How about yourself?
Pretty good, man. Pretty good. Appreciate y'all jumping on. So I'm glad and happy that y'all have are taking the class. Let's see, Connor.
Hey, I'm here too.
Okay, all righty. That was my next question.
Yep.
Let's see. Got Eric Martin is in. Eric Martin is in, and Jameson's in. Jameson, did you get some rest, man?
Yeah, I'm good.
All righty. Good. Got Justin Sokolowski. How are things down there in Jacksonville, Justin?
Oh, they're good.
That's good. So are you in school now? Are you taking classes now at ECU or?
Yes.
You are?
Yes.
Are you doing all that remote?
Yeah.
And you're getting a degree in industrial engineering? Or what are you taking at ECU?
Right now, this semester, I'm just taking a few electives that I needed.
A few electives that you need. Okay, and then you're really shooting the transfer to UNC Charlotte for electrical engineering, right?
Correct.
Yeah, that sounds good.
I just got a few electives, and I'll have my bachelor's after this semester, and then I'm gonna transfer over.
You'll have your bachelor's from ECU.
Yeah, in industrial engineering, I'm gonna transfer over to the electrical engineering program there at UNC Charlotte.
Yeah, I know that the electronics degree that you've got and what I've got, we got the same electronics degree, electronics engineering technology. That years ago would transfer to Charlotte to get a BET, a Bachelor of Electronics Engineering, like a bachelor's in electronics.
Yeah, they changed it to electrical. It's still essentially the same classes and degree. They just changed the name to electrical engineering.
They probably broadened it out.
Yeah.
I bet they needed to, because it's hard to find work in nothing but small electronic, like component level. That's hard to find.
Yeah.
There's not a lot of jobs, not that I know of, in North Carolina. You may have to move way out somewhere,
Yeah.
Atlanta or Silicon Valley or somewhere to get something like that to have better chances of it. But anyway, I had to industrialize with what I got in electronics, and then it worked out fine. So, okay. So Jameson's in, but it's good to know that that you're getting this class because you got to have it to go to Charlotte. So that's good.
Yeah.
I went on a tour to Charlotte when in 1986 before I graduated and got my engineering degree, and we went in there, and I was considering maybe getting that 4-year, but I never did do it. But I know one guy that did. He transferred and got his 4-year in electronics engineering. I know one guy that did it, and he works.
They just switched the name over maybe 2 years ago.
Yep.
If even that.
Yep.
I looked at it a couple years ago, and it was still electronics engineering.
Well, here our college dropped electronics engineering because there was not enough jobs in Sampson County to support it. We had most of the people that graduated in my class did not find jobs using it, and I didn't find one with just electronics, but I got into plant maintenance. My first job was an electronic technician / maintenance mechanic. So I did A to Z, and I got hired because I knew electronics, but I also had to learn the mechanical stuff that I didn't know, and they showed me all the mechanical stuff, and so I was turning wrenches 1 minute and troubleshooting PC boards the next. So it was you had to be pretty versatile. You got to be versatile. You need to be versatile in Sampson County to have a job, and if you are, you're gonna have work. So, yeah. Okay, so that's good. Who else needs help at this point, or has something that they can show as far as the program? Whoever speaks up first, we'll just go in that order.
Oh, I gotta start doing that.
Yeah. The goal tonight would be to have everybody to show me. Now there are some people. Is Dylan Shook's not in yet, so everybody that's in right now has shown me their Emulate program for basic logic, and then on the PLC version, Justin Sessions, McGill. Everybody that's in the session has actually showed me that. So everybody that's in right now with us, you can show me the emulator for your sump pump. And once you do that, go ahead and write it with the real IO and then send it to me, and then we'll run that. And I'm not going to spend a lot of time on tracing wiring and stuff tonight like I did the other night. We only need to do it like one time, you know. I just showed you the wiring for the HOA switch. The only thing I hadn't showed you is the wiring for the float switch. I will show you that. And I can go ahead and do it kind of while somebody's getting ready to show me something there. I'll do a quick screenshot and well, no, with my camera, with the webcam. I'll show you. Now, so y'all see the float switch in the drawing. Let me go large here where I can see what's going on here. Okay. Now I can tell what I'm pointing at here. So y'all see the hold on. You see the float switch right there? Can everybody see that?
Yep.
With the ball.
Yeah, I see.
So that the real physical device is right here. Let me get. This is the real physical device right here. So when it's in the down position like that, it's going to be open like the drawing shows. So let's see if I can give you both at the same time. Yeah, I can if I can get my orientation. This is weird because I got to go the opposite way. Oh my gosh. Okay, here we go. I'm going to go back that way and that way. Okay. So the float is in the down position, so it's drawn open the way it is here on the diagram there. Now, when the float rises and you get water, then it's going to cause it to float like that. And you can actually hear something. You hear that clicking? Y'all hear that?
Yeah.
So when it flips over, you get that click. So there's a ball inside of there that makes contact with some metal contacts in there. That ball is evidently got a conductive material around it or something. So because when it flips, it makes a micro switch in there and it opens or closes. So that this is a two wire float here. Now I'll show you with the webcam the wires that go from. This is so backwards here the way I'm doing this. The 24 volt DC that has to go to the left side of all your devices, all your field devices. It also goes to the float switch, constant 24 DC. And then it leaves out of there with your off and on signal with the float, and it goes to input 6. That's a new input I added in there. So I'll just show you how it's physically wired with the 24 and then the signal going into the PLC. We'll go over that real quick. So I'll get the camera. And let's see. Here, let's go. Now, so that's the float. Now, the end of the wires go right here, this black cord. So you see that black cord I'm pulling on? Looks like a drop cord. Now, that cord it's got 2 wires. It's got a white wire with red tape on it. And that white wire with red tape going in there that's 24 volts right there. Where that jumper set is, that's a 24 volt. And if I pull that wire, that comes from the power supply up top. You see that orange wire I'm pulling on? That's your 24 volt up top. That's what leaves the DC power supply. That's what's leaving that 24 volts out. And it's the power supply has 120 coming in from the wall. So that is just simply got a drop cord coming in to a terminal strip to a little circuit breaker, and it feeds 120 right out of my wall at the house into this thing, and it gives me that 24. So on the terminal strip here, the white wire with red tape has 24 going into the float. So it goes down that cord through all this stuff here to that float. It goes into it 24, stays 24. And then it leaves that black wire right back through that cable again. It goes right back up here to this black wire that leaves that same cable. That cable's only got 2 wires in there. It doesn't even have a ground. And so we pull some wires out here. you see where the black wire's going right there on that terminal there. So that terminal there, it comes out the top with an orange wire. And so that's the output of the, that's the signal leaving the float. And we go up to the PLC, and then let me stand up. I got to set the camera down here. So this is the wire coming from the terminal strip from the float switch. And I've got it going up here. And I stripped it, and I pushed it into the push pin connectors, like we went over the other night, and I added it to that new input. Okay, and I'll just show you again, just in case. I'm not sure if anybody missed how that's done. So when I went to add that, this is the wire right here that I added. Right there. And let's come back just a pinch. Rotate like that. Okay, you can see that really good there, I believe. So this is the wire, the last one, the last orange one. I'm gonna push this spring release here with a screwdriver, push in, and when I did, the wire came out. You see that naked wire there? That's actually in there, in that hole. I had to push that spring release, and I pushed that stripped wire down in the hole. We're gonna do it again. I'm gonna put it back in. So here, I go right to that little orange thing and push. And when I push in like that, that hole opens up inside a spring, moves out of the way. I push the wire down, all the way down in there as far as it'll go. Far as it'll go, way down in there like that. And when I let go with the screwdriver, then it's locked in. So that's the style, that's the way things are going. With PLCs and all, they're making everything quick release, and then I'm checking here to make sure I don't have any wire sprig sticking out hitting anything else, and I didn't. Now, if later on if I had to replace that PLC, you wouldn't have to take all those wires out like I just did. You just go up here at top and bottom and you squeeze those clips. Let's go back some. The only wires you have to unwire would be the power wires. You would unwire those with a screwdriver. That pops off, and those three would come out. Ethernet cable would come out, of course, at the bottom. But all of your I/O in here, you would press the top and bottom clip like that and just pull like that, and the whole thing comes off as a unit. That's pretty nice, isn't it? So you bring that back, and if you have your second row wired, if you were using all 16 inputs and 16 outputs, you would remove the other one too. And then you would put your new PLC in, wire your power, hook your network cable back up, and then pop in your I/O here. Snaps in quickly like that. Snaps in nice and fast like that, and it just saves a lot of time, So pretty good, huh? The only thing I don't like about these is you can't put a voltmeter directly on these to measure them. I like modules like this that you can actually put a meter, probe it right at the module, and check voltage directly there. You can't do that with these. So what I did is, so that you can check it near the PLC, is I did this. All of these wires here, I've got them going to an intermediate terminal block here. You see that?
Yeah.
So what I did, I went from that control box, instead of going from the control box straight to the PLC up here and not having anything between for measuring voltage, is you've got to have some measurement points somewhere when you go between a control box like this. You go between a control box like this and the PLC itself. You don't want the wire straight box to here, because then you have no test points that are easy to get to. You have to physically go open that box up and measure things in there. But what I did, I went out of the box here, out of the bottom of this box here, went to an intermediate in-between terminal strip. Now I can do voltage measurements there, and I've got that near the PLC. You see, this is like right up under where this is. So put you a strip like that kind of near the PLC, and then you have some test points for fast troubleshooting with a multimeter. But of course, you have your LEDs up in here. You know, you always have those. But if you didn't get a LED and you said, oh, I want to check voltage here, well, you can't, because the way they got them designed, I think that's the only thing I don't like about these. I like this a lot better. Here you got real screws you can go to and put a meter on there, bam, and measure right here at it. But here, I put that there just to kind of take the place of this, you know. So, and that's, you know, there's ways of working around things whenever they shortcut. They're shortcut things, you know. For convenience, they do this, but then they're not making it easy for meter using, you know. So that's, I don't know. That's your trade-off. So anyway, so basically that's it. That's how it's wired. That's how the float switch is wired. You know, it's just that little that cable with two wires in there, with a white conductor and a black one, and there's not even a ground wire in there. And for 24 volts DC, you know, it's not going to be dangerous anyway. So I wouldn't recommend putting AC 120 volt AC anything in water, because if it ever develop leakage, then it's going to be quite a hazard, you know. So anyway, so since we traced the wiring out, and also let's see, the two wires that leave here, let's go back. That switch is right right here. So the two wires that leave it, you got 24 coming into both sides here, to both contacts that I showed you behind that. 24 volts entering both of those contacts on the left, and then you leave on a hand wire and you go to input 2, and then you leave on auto contact and go to input 3. So those two for input 2 and 3 are they're in this group here, you know. So you have input 0 up top, input 1. Now the two that I have in my hand here are input 2 and 3 right there. Those two are. So these two here, they came from the HOA switch, you see, and that's what I've added into there. So it's very simple. Does anybody have any questions about the wiring? And I feel bad that you're not able to do the wiring because of this virus thing going around, but do y'all have any questions about how you know, how the switches is wired, the terminal strip, and then the input module itself? Anybody have any questions?
Yes, sir.
How about questions about the schematic? You know,
I got my emulator one done. I'm about to do that.
Okay, so if at any point, if anybody is scratching their head saying, I don't really know what I'm looking at, you need to say something, because if you don't say something, I'm just going to assume that you're okay with it, and we'll just keep trucking, you know. But I'll be glad to stop at any point and answer any questions, because I know that a few of you have not had any electrical classes. But again, the electrical is actually quite simple. If you know, does it seem simple to y'all?
Looks pretty straightforward to me.
It is very straightforward. PLC wiring is not complicated. It is not at all. When you're in motor controls, the wiring can be complicated, but what you do, you take hardwired circuits from motor controls that are complicated, and you actually simplify the wiring here, and then you do the complicated part in the program, in the logic in the program. You do that, you know, with your, you know, what you're creating in the program. So then what's outside the PLC is never complicated. It's always very straightforward. With every field device gets a separate input, a separate address. It's kind of like every person has a different address at home, you know. So those devices, they have to have individual addresses, and the same thing with them outputs. They've all got to have. You don't see anything out there sharing outputs, do you? Nothing. Every starter's got its own separate output. Now, it doesn't mean that you can't do it. You can have 2 starters running on one output, but it's not advisable, because the relay output that's on this module here, there's a limit on how many amps that it'll put out, and you're going to wear that output relay out sooner if you take one output and you feed, say, 2 starter coils. So it's not advisable. You know, you want to have one output per starter coil. And then you can troubleshoot individually with the LEDs that are up here. Each LED is going to represent a separate starter, and it just simplifies troubleshooting a whole lot to keep everything separate. Everything's got a separate address, a separate wire, and then the way it all relates to each other is going to be done in your program, of course. Okay. All right. So let's reposition the camera here a little bit. Back out. Again, the wider angle camera that I've got ordered, it ain't even supposed to ship till June the 30th, which is kind of got me disappointed there. When the virus hit, everybody and their brother started ordering cameras, and I guess some people got in ahead of me. And there was a back order on them at Granger. Let's go up again. Trying to get where you can see the that's going to be all right. Let me go up just a pinch. Good. Let's see. I've got a microphone stand for my PA system, a boom stand here that I got rigged with a webcam. I'm rigging what you call engineering. You ever heard that term? Y'all ever heard anybody say engineering?
I've heard you say it before.
Quite a few times.
This is engineering here. All right, so you'll see the PLC, the lights, and they're not going to be in focus good like that. You'll see the buttons and the HOA, and then you'll see the starter, that little red indicator right there. That's about the best I can do view-wise to see everything. So it'll kind of we can make do with that. So let me cut the power on, and then whoever's got the first program, I will put it in there. Okay, I got my headset back on, power's on, and so I know Kenneth, I know you emailed me yours, so I'll go ahead, and since I received it first, we'll go ahead and do Kenneth's real PLC version of the Sump Pump now. So let's, and again, we'll kind of, whoever kind of speaks up first, well, that's who we'll go to. Let's see, we'll do screen share. And let's see. I haven't opened up the studio yet. Let me open up Studio 5000. Let's see, I cannot do that. I do screen share. There. And let's go studio, existing project, and go under student, Sump Pump with Latch. Do y'all see the studio coming up?
Yeah.
You do? Okay, good. I know when
I'm
I
not
switch.
100% sure that one's going to work. That's the one I added the lights in afterwards.
Okay, well we'll look at it before we download. Let's do a spot check. For those of you that Kenneth has added some lights in here since I do have 3 lights that are already wired. He wanted to have some lights in the program, so we're going to find out. See, does it make sense what he has? Okay, do y'all see his program?
Yes, yeah, we can see it.
Yeah, we can see it.
Now, tell me if you see something wrong here. Let's hold on a minute. Let me let's go over. Now you see where it's wrapping over here, over on the right. It does a little wrap around. It's doing that because we got a problem there. Yeah. You put some coils in series, and you normally would not do it that way. I think you can get by with it in studio, but it's not standard practice to do it that way. Your outputs would normally be parallel.
Okay, I didn't know that.
And the reason why, we hadn't gotten around to mention it yet, but normally outputs would be parallel. I think you can series outputs in this software, but I wouldn't do it because as soon as you step back to the RS Logix 500 software, it will not let you do it. And in real life, you would not series outputs no way, because let me just kind of tell you what would happen here. If you physically had a circuit that was wired like this in real life, y'all see my mouse moving around?
Yeah.
Now, if this was not a PLC program, if this was hardwired circuit now, just hardwired stuff, and you left these devices and you went to a coil and you went in series to another coil and then a neutral, here's what would happen. And listen good here. That 120 volts, it would be right here. The 120 volt would not be across just that one. It would be 120 volts from here through one, through another one, and then a neutral. You would end up with 60 volts across that coil and 60 across that one. And both of them would sit there and they would do this. They would chatter. They would go. They would make a noise for low voltage. Does that make sense?
It does.
You would be putting 2 coils in series with 120 volts, which would be 60 volts across each one, and each one of them starters would sit there and they would like I got my hand moving in the camera. They would be in and out, and they wouldn't be able to get all the way in. They would just be sitting there chattering like how many of you have had a battery go low in your car or truck, and when you hit that switch, you hear something go tick tick like that. That you hear something chattering.
Yep.
It's chattering. Things are chattering. Relays or starter is chattering because of low voltage. That the armature and the starter tries to move and it can't, and it does and it can't. And your relays are trying and they can't, under low voltage. So let's let you, before we run this one, let's let you put this in parallel with that one right there, okay?
It's already done.
Already done? Okay.
I'm about to email it to you.
Okay, and let me look before you do it. Let's look over, see if there's anything else going on here. Okay, so for the hand input, hand is 2, stop is 0, start is 1, and then the starter is output slot 2, data 1. That's good. Auto is input 3. That's good. The float is 6. Now for hand, you're saying that when input 2 is on for hand, that's fine. That'll work. You're sharing that hand input to turn a yellow light on. That'll work. And an auto is input 3, and you're sharing that one to turn on a red light. That's fine. That'll work. You just need to parallel that green light with that starter coil. Not that it wouldn't work in this program, but it can make you think something that it would only work in 5,000. It wouldn't work nowhere else. It wouldn't work in the 500, and it wouldn't work in real life outside the PLC. So
makes perfect sense.
Putting load devices in series is very rare. It's rare to do something like that. So okay. So I'll hit close on this one. And let me open my email back up.
Hold on, it didn't save for some reason.
Mm-hmm. How's McGill doing?
What's going on, Durwood?
How you doing today, man?
Pretty good.
Good. Jump right in and hold on. We're rolling. This train is rolling. This train's rolling. Woo woo! It's rolling. Yeah. And just so you'll know it, Kenneth thinks the class needs to go like twice as fast as it's been going. I don't know if that's possible, but I'm going to try to speed up a little bit.
I didn't mean it that way, Mr. Durwood.
I know. I'm just kidding. Yeah.
All right, hold on 1 second. I'm getting ready to send it.
Okay, I see Dylan Shook sent me something there. So while you're doing that, let's see, ACD, and then so Dylan, what's the difference between Dylan? Can you hear me? Dylan Shook. He may not. I'm just going to say both of these. Let's see. Save as. Let's go here. Let me make a folder for Dylan Shook. I'm saving Dylan Shook's while I see him here. And let's see, save as. That's another one of Dylan's there. So save. All right. So I sent both of the programs he just sent, and yeah. Can y'all see my email?
Yeah.
Okay.
Yeah.
Okay, Kenneth, so have you already sent it or not?
Yeah, I've already hit send. I don't know why you ain't got it yet.
There it went. There it went right there. Yeah. Well, it had to go through a bunch of stuff out here between where you are and where I'm at. It went through a fiber optic cable and down under the ground at my house, went into a module, converted, went through Ethernet, went to a router, and went through another Ethernet cable back here. So I reckon that won't too bad. So save as. There. Yes. Okay. So now let's go back to Studio and open. And that was a new one.
Yes, sir.
Right. Go there. Perfect. Yeah. Does everybody see what he did? For his first version, he had an output coil in series with another one before it went to neutral. And that's, even though you can get by, I think you can get by with it in Studio 5000. I don't advise it because it's not a good practice to get into. You can't do it anywhere else. You can't do it outside the controller. and you can't do it with RS Logix 500. So
that's actually the way I wrote it the first time, and then I overthought it and rewrote it to be in series.
I think when I went to the Rockwell School in Charlotte, that guy was actually showing us that it could be done. He was saying you could do it, and everybody was like, everybody was tripping. It was used to doing it in 500 software, and he kind of busted out laughing. He said you could get by with it, but
Well, logically, it makes sense to do them in series, but physically, it makes sense to do them in parallel. Like you said, it just wouldn't work physically.
It wouldn't work physically. No, it wouldn't. And just so you're consistent with everything you're doing, I like doing outputs in parallel. So anyway, but some people will use everything that they can get by with, everything that will be allowed to do use it, and that's perfectly fine. It really is. It's fine. But I'm enough old school and I'm enough practical that where I like to see things in the program look as close as you can to a hardwired circuit, and it's just going to be easier to troubleshoot.
Yes, sir.
It's just going to make more sense logically whenever you troubleshoot. So that was fine. That was fine. And let's see. Let's check that output 4. That's right. So you got green, yellow, and red there. That's fine. So that's good. Now, what you're seeing everybody else is he's added lights in there. I didn't ask you to do that, but I hadn't asked you yet to do it. I was going to ask you after you showed me the standard version of it, you could go back and add some lights. So he's got green when the pump is running, yellow when you're in hand, and then red when you're in auto, which, that was kind of his own original idea. I was going to say have it green when it's running and red when it's not running. But this is fine because with PLC programming, you really need to get creative about it and try some stuff that you got on your mind and get creative with it is what I say. I say do it, and you may have some different ideas than I do. Some may be better, you know what I mean? So I say do it. Now, so let's go. Now, how do I get the program down into the PLC, Kenneth?
Can you hear me?
Yeah, I do now.
Oh, my microphone was muted. You can go up to communications.
Okay.
And who active?
Right.
And click on your Ethernet 1. And then your controller. And download.
Right. The reason why we're going through who active is because in a real plant setting, you're going to have a lot of IP addresses to show up there. You may have 20, 30, 100, or a couple of hundred of them to show up, depending on where you're at. I've been in one plant that had 300 VFD drives on one network down at Unilever in Rayford. 300 PowerFlex drives, different kind of drives on one network. 300.
That would be madness to try to keep up with.
And it might have been, and it may have been 350. It was 300 something drives they had on one network. Yeah. That plant was that was the first plant I had a chance to go in and teach in, to go into it and teach. Once I took my 3 levels of Rockwell for the Studio 5000 that we're learning now, our college in Sand Hills pitched in and went 50-50 and paid for me to go to level 1, 2, and 3 on this software. So and their reason was so I could go in Unilever and Rayford and teach them in that plant on their equipment, because they had new equipment and none of them knew this software. And so they got me to go to school, and then for me to come in there and teach it, and then they saved a pile of money by paying for me to go one person and come back and teach, 18 guys, So it was a big savings for them, and I was happy it was a blessing for me to go, and all of that was set up years ago that I went and did that's got me ready for what I'm doing now, So if I hadn't had that chance, I would not have known this software as easily, because I've been to where the best of the best are at Rockwell teaching this stuff, and it's just unreal how good them guys are. So all right, so now let's do on our do you see my hand waving in the webcam?
Yeah, I can see.
Now, so you see that, plus do you see the actual logic on the screen too?
Yes, sir.
Now, let's do the switch. Right now it's in off. So hand and auto is not lit. Now let's go to hand. You see hand light up?
Yes, sir.
Now also look over here in the webcam. You see that yellow light come on over here?
Yes, sir.
That his yellow light's coming on too. So the light's working fine. And now the top rung in the program is now ready. Now also look at that stop button there. Stop button's already made, ain't it?
Yes, sir.
And look at what happens in the screen when I hit that red button over there in the webcam. I press the stop button and look at what happens. It goes away. Now let go of it, it comes on. And that's because the physical button is normally closed. You see in the picture here?
Yes, sir.
It's physically closed. So that's why you're getting the stop button is lit in there with an examine on instruction. This is kind of hard to wrap your head around, but we use like a normally open symbol in here as a instruction, because we've got that normally closed button outside that's already made, and by it being made and voltage coming into that input, this is the instruction that you have to use. When you have an external normally closed contact, you got to use an internal examine on contact that looks like normally open for that to give you what you're looking for logic wise. So is everybody comfortable with that?
Yes, sir.
That's why you have to have that. And I know it sounds backwards, but it won't work any other way. That's what that type of an instruction is looking for. It's looking for voltage to be true. And then when I press that physical button and break it, there's no voltage coming in that input 0, so therefore that instruction is not true anymore. Okay. So now I'm going to press the start button. If you see in the webcam, I'm pressing that little green button there, and I press it briefly. And what's wrong here? So something's physically wrong.
I think I know what's wrong. Isn't the data supposed to be 0 instead of 1 for your sump pump starter coil?
Well, on the start button's not working. Hold on, I'm pressing the wrong one. Look, it's down here. I'm sorry. You see on my panel, I got a green button up here, and I got one down there. I think I'm using this one. It is. Look, that top left green button on my panel is not wired yet. That top one's not wired. The second green button is wired if you look at the webcam. That's what was wrong. Let me hit stop again. So if you look where my hand is in the webcam over here, it's the second green button on the left of the screen. So I'm going to press and briefly and let go. I'm going in now. You see it, and then let go. Now it's gone away. So that gave us that energized your starter coil and a green light. And when the starter coil energized data.1, that output, it caused that same address to go true, which is giving us what you call a logical holding contact. You didn't have to wire it in, but it's called logical holding, not physical holding. So it's internal in the program. You can do things and not have to add no wires. So you're running right there, and if you see outside there, you got a green light and you have the yellow light, right, that he's added in there. So in the webcam, you have the lights over here, and so does everything look nice and clear from the logic appearance and then from the physical board where my camera is?
It looks right to me.
I think you can actually double click on the webcam and maximize it and kind of, go back and forth. And I think if I do it, no, it didn't do that. I think I'm doing some other stuff here. I've actually lost some things. Show grid. Show smaller. No. Anyway, I'm still learning. Oh, I'm still learning Zoom here. I clicked something here and it did something I was not expecting here. I had all of my views were like in a single line. Okay, yeah, I see it now. I've got it back. I'm still learning Zoom here, man. Some different things about it. Okay, so now let's switch it. Let's go to the HOA switch and go to the center position for off, and let's go to automatic to the right. You see automatic lighting up there, and when that happens, you're also getting that red light on out here on the controller that Kenneth added to it. And you're also getting the auto signal that parallels around. That's your OR circuit right there. You have hand or auto. So it's going around. Can y'all see my mouse moving around?
Yes, sir.
Yeah.
So you're going around now in auto. And then so between auto and the starter coil, what do we have?
Your float switch.
The float switch. So let's get the real float switch up and let's get it in front where you can actually see it. So right now, that float is dangling in a tank. And then all of a sudden, water is sent from the plant back to waste treatment where this pump is. And when it rises like this, the water comes in, about 10,000 gallons or so comes in, and then it goes up. You see it change?
Yes, sir.
So when I bring the float down, you see in the camera, the float's up, and it's made. And then the pump runs a while. It pumps water out of the floor into a treatment tank, and then the float drops. So watch the float in my hand drop. It's going to drop. You see the contact go away?
Yes, sir.
So, and then another area of the plant, they do a cleanup, and they're sending another 10 or 12,000 gallons of water back there. And here comes that float. Bam, there you go. So then the pump's going to pump again. It's going to pump until it gets down, until the float drops again. Here goes the float real slow. And it will be slow like that as that water pumps out of the floor. Look at my hand moving, going down. Just let the float, all of a sudden, the float dropped out. And so that float is, you call that float as a pilot device. And a pilot device is anything that controls a coil. Okay? Pilot devices are input devices. So all of your input devices can be called pilot devices, and that float is the pilot for auto. So that's what's driving that coil. If I go up and down like that, you see it changing, and it's
Yes,
right
sir.
on the dime. So if that water is sloshing around, if it's real turbulent in the tank, then your starter's going to follow it. It's just going to be abrupt like this. You see it?
Yep.
So it's gonna track exactly with it, and let's go. I'm gonna go large screen. I'm gonna cut the screen share off, and let's go back to full screen. Now, do you have like a full screen view now of my webcam?
Yes, sir.
Okay. Now let's go. Let me move this stuff over. Now, can you see the starter down here? It's kind of fuzzy, ain't it? But
I can see it all right.
you see it going in? So
Yes, sir.
watch that, the float. You see it? So it doesn't matter how fast you go with it, that starter's going to follow. And also your lights over here, Kenneth, are going to follow right directly with it. So the float goes up. See if I can get over here where you can see everything at one time. Floats down, up. You see that the green light come on. So the green is for the pump running, and the red is for auto. Now let's add a troubleshooting element to it. Let's say this float here goes bad, and all of a sudden, when I go up with it, it doesn't make it come on. So the first thing you can do is to go into your program. Well, go to your switch, and over here and go to hand. And you're in hand because he's got a yellow light coming on now. You're in hand, and then try your start button. You see it work? Now, if it works manually in hand, then what that's telling you is that your starter's fine, all your controls are fine. You got a bad float. Something's wrong with the float. It's either you got a loose connection, or the float itself is bad. Does that make sense?
Yes, sir.
So that's the whole reason behind having that hand section in there, is so that if this fails, you can still run that pump if this here goes bad, okay? And you're not going to be in a jam with a flood in the place, because if the sump in the floor fills up to a point, you're going to be walking in water, and it's going to be a hazardous condition. Okay, so let's go back to exit full screen. Yeah, that's the reason for that parallel logic, or that OR, so that if you're going to leave it in auto most of the time like that. Can y'all see my mouse moving now?
Yeah, I can see it.
Yeah.
So that the auto section is what you're going to run with most of the time, so that nobody has to sit there and monitor that pump area. Nobody wants to stay in waste treatment or wherever you're at and just sit there watching stuff, and you don't have time to do that. But that hand is in there just for what we're doing right now. It's a backup if that float fails. And it's also a way of proving, is it the float that's bad? Is that why it's not coming on? Or is it the starter itself that's bad? So it could be the float bad or the starter. Now, if you go to hand like we did, and you hit start and that starter doesn't come on, then it's probably not the float. You know what I mean? So that gives you an option for troubleshooting. You can narrow it down by having a choice of hand and auto. And if it don't work in either mode, then chances are is your starter's probably bad. You probably have a bad coil. The coil may be burned open in there, or a loose connection at the starter. It could be a loose wire or a bad starter coil. Or it may be tripped. The overload may be tripped on the starter itself. That you have. Let's go. Let me go back to full screen again with the camera. Stop share. Full screen like that. Yeah. Here, you see down here, you got where it says ENC, normally closed. Y'all see that?
A little bit.
The 95 and 96, that's your contact. That's your overload contact. If this overload pops open, that normally close is actually going to pop open, and your starter's not going to run, because right, y'all see that pretty good?
Yes, sir.
The 95 and 96 on for overload relay is the two terminals I just showed you on the bottom of that starter, the two on the lower right. So here, if something goes wrong and the motor itself is drawing too many amps, that normally close is going to pop open, and if it does, you're going to lose your neutral leg for that, and that starter is going to disengage. It's not going to be made anymore. So that's a possibility there too. So if this doesn't run in hand or auto, then you may have to go over there and try pressing that reset button, that red reset button there. I mean the blue. You see the blue reset button?
Yep.
So you could try pressing that, and if it's had time to physically cool down enough, then it would let you reset it and try again. It was your start button. These things heat up now. If it's still hot, then it may not let you reset. You have to let them cool down. And when you try that, you could try starting again, and if it runs, then you're okay. But if it reoccurs again, if it keeps tripping out overload, then you've got, let's go over here where the motor is. You see that motor?
Yes, sir.
That motor's got bearings in it. Okay, the shaft in there's got bearings. So if the front bearings or the rear bearings, if they get seized up and that motor goes bad and it locks up, it's going to draw too many amps, and that overload is going to trip. That 95, 96 is going to trip open, and it's going to keep tripping. So you can reset this all day, and if you reset it, it cools down. You reset it, and it runs. if the motor is locked up and jammed up for some reason, it's just going to trip again. It's going to keep happening. So if it happens twice, don't reset it a third time. You got to examine the motor and go to the motor and physically spin that shaft and see, can you spin it? If it's a pump, if it's going to a pump, see if you can physically turn that shaft like I'm doing there with my finger. See if you can rotate the load and see, is it in a bind? Because if it's in a bind, then it may be if it's a belt drive that you're running, a belt drive pump or something, then you may have something, not the motor, but it may be something that the motor's driving that may be jammed. So if that's the case, you got to decouple where the coupling where the shaft here is, where the coupling goes from here to whatever you're mechanically driving. You may have to actually decouple the motor from the device that it's driving, and decouple them and then run the motor. And see, does the motor run on its own without the physical load it's driving? And if it does, and it doesn't trip, then you probably got issues in the bearings on what you're driving that shaft is coupled to. Does that make sense?
Yes, sir.
Okay, so that again, when the issue of it not running could be something, you know, all of the above what we've been talking about, you know. But let's say if that motor jammed up, now if something on the machine jammed up one time, and it was a one-time thing, and you go over here and you reset that blue button here, okay, and the operator unjams it and you reset it and you run it, you never see it again. That was just a one-time thing. It was just a jam up on the machine. You know, the material jammed up, and that was just something that happened, you know. But if it keeps tripping over and over again, I wouldn't reset it but twice. And if it's beyond that, you need to be examining, first of all, is the motor, is it bound up for some reason? And then if it's not bound up, but it keeps tripping, then you got to do an electrical test on the wiring and do an insulation test on the motor, because the motor itself may be short-circuiting inside the motor, you know. And we went over that in motor controls. You remember, some of you guys have had motor controls with me, and we went over how to actually do an insulation test on the windings with an insulation tester. So if anybody in the group has never seen that done, I can do it at an in-between time, maybe like after normal class. I could do it. I don't want to tie up regular class time on doing something that we did in motor controls necessarily, because I think most of you have actually seen it. Most of you have gone through it with me already.
Is that motor controls class available next semester?
It's a spring class.
Okay.
Yeah. What's offered in the fall is Introduction to Electricity, ELC 111, and Residential ELC 113.
Okay. I'll look and see if those are in my electives.
Mm-hmm. I think you may be able to apply anything we're doing in your electives. Could be.
Okay.
I would guess, because it's a plus. You're telling me you're going to go into a plant and work. You want to be an IT guy that's connected with the office plus the plant floor. Is that right?
Oh, honestly, I'm trying to get my degree. I want to go into some kind of electrical engineering, but I've been told that networking and electrical are going so much hand in hand now. The best was to start with a networking degree and then try to go for either electrical or electrical engineering.
That's smart. It is. You're going to knock it out of the park, man. You really are. Yeah, it's what you're heading for. You know, you're going for the gold, man, and that's good. You know, it's so you're heading the right way. That's good. Okay, so let's exit out of here. So let's go back to your program is great. Okay, I'm gonna put you down for 100, and then we'll take who's next. Let's see.
Mr. King, I got a question for you.
Okay.
I think, because I'm putting it all together now, I think I clicked the wrong thing when I was choosing the actual PLC, because when I go to alias, I only have local 1 in and out. I don't see local 2. Is there a way without making a whole new program that I can go and add?
Yeah. Yeah, just do a screen share. You got to add your module. You probably didn't add. You probably didn't add slot 2 module.
I don't think I did. I think I did. Okay, here we go. So here's my.
Right. You can just close that out. Yeah. Go down into your expansion IO. That's what you see. That's what you didn't do. You got to right click there.
New
and new module. You got to add that module.
Okay.
Yeah.
And it was the 1B or IQ.
It's on the paper that paper I sent you. It's a 1769 OW16.
Oh, okay. That's why I clicked the wrong.
If you see the paper I got in the webcam.
Yes.
That new one that I sent y'all last night. It's got that information was on the first one, but this shows you the float and all.
I got you. So it's this one right here, the OW16.
That's right. That's it.
Okay, just click create.
And then you've got to go. You give it a name, which you can just say relay output. You have to name every module, and you could call it just an output. You can call it anything you want to. Ho, don't do that. You got to change the module definition to a firmware 3.1.
Okay.
Physically, the firmware. Just let me tell you again. The reason for that is you see that box I'm holding up in front of the screen there.
Yes.
Do you see where it says F/W 3.1 firmware 3.1?
Yes.
So that's the factory box that the module comes out of, and it tells you that on there. Plus, it's on the side of the module. If you look at it before you insert it, on the side of it, it's on a sticker. You know.
I got you. That's actually what I did wrong. I forgot to change the
module definition.
Yeah. Okay, there we go.
Yep.
Okay, I appreciate it.
Uh-huh. Okay, so who wants to either show me a circuit or who's actually ready next?
I have my emulator ready. If you want to see that, Mr. Durwood.
Okay, that's Bill and Ivy.
Yes, sir.
Okay.
Can you see it?
Yeah. Uh-huh. There you go. Uh-huh. That's exactly right. Well, you wouldn't hit the start button for Aldo. You can release the stop button. Yeah. Let your stop button go back to close if you want to. Well, you're fine right there. You're good. You're working in Aldo. That's fine. Now toggle the float off now. That's fine. Yeah, that's good. That's good. That'll work.
10-4.
Just remember when you do the real thing, for your stop button, use an examine on, not an examine off for that stop button.
Yes, sir.
On the real one.
Okay.
Yeah. Okay. Let me go ahead and make a note here. You got that's Dylan Ivy for Emulator Sump Pump. Okay. And Kenneth did his. Let's see. Let's see. I've already got a. Let's see. Let me record this over here. Branch. Was that Sump?
Durwood.
Yeah.
Hey, I'm having a problem. I don't know. My mind's drawing a blank tonight for some reason. All right, now to make my program for you to try out, how do I put my daggone inputs out in?
Do a screen share. You right click on your question mark. Well, hold on a minute. Hold on a second. You're doing the emulator, right? You're just doing the emulator now? No, hold on a minute. That's what I see you're doing there. Yeah, you don't need to do the emulator again. You've already done the emulator. You got to create it with a Compact Logix controller. That's what's wrong. Yeah, you're actually doing it with the emulator program, with the emulator processor again. So I think you can change it. Look, go down a little bit further where it says controller, EMART, and Sump Pump Logic. You want to go up higher, way up. Go to the top part of your organizer. Right click on that and choose properties. I'm gonna see if you can change the controller type from right there. Yeah, go up where it says change. So you got to emulate controller. It's got to be a real controller. So do the drop down there. I hadn't showed y'all how to do this, but it can be done in here. In the middle of what you're doing, instead of you writing everything all over again, you can change it in midstream now. So you would go down to a 1769 L24ER. It's in that Tupperware container on the sink with a top on it. So you would go down to the information that's on the paper that I sent you. It says 5370. You got to go to hold on. I'm sorry. Wait a minute. You want to go to 5370. 5370 controller, and it needs to be a L24ER in that paper I'm showing you right there. L24ER QB1B.
That for the next one or this one?
I think you better click a little bit slower than that. That's the one you're on now. Kind of tap your button up and down, kind of one line at a time.
It's not a bit.
Why did you get into bed?
So I can't.
Wow.
I can't control.
I
So
got
I
into
literally,
it.
Ashley was like, "Hey, you get that so bad." I was like, "I know, but I can't control it."
Okay, hold.
I tried to take him out. I mean, I literally couldn't even.
5370. Okay, yeah, go on up. You want to go up to the L24ER.
You gotta go in? I thought they were just taking from outside.
Hold. The QB1B, that's it. That right there. That's it. And hit OK. Hit yes.
No, that's probably rail that you've been rumored.
Just give it a minute to make that change. Does it make sense what we're doing here, Eric? Is it making sense, Eric, what happened? Okay, now you got the correct controller now.
Like, that's the real dance. Like, when the people know it, they're gonna like, whatever. But I don't think I could ever.
Now you're fine right there. Go ahead and hit apply. Hit apply, and then hit OK.
Yeah, I can't take a shit for that. Especially he'd be scared.
Did you hit OK?
Hit somebody.
All right, now.
Now
Listen. Now you got to go down there in your expansion IO, and you've
You
got
wanna
to
turn
add,
it
you got to
over.
add that module.
Okay.
Right click on expansion IO.
Brooklyn does not trust that vet. And
No module.
she's heard stuff and like working at the other vet at Durwood, and she hates it. Like she's not letting them take my job. I don't know what could they possibly do. I mean, they're probably going to treat them like.
Hold on, you hadn't got the module in there yet.
I don't know what they're gonna.
I mean,
Now go down in that list, and you're going to
She
choose
said they
the.
don't do right. Like,
Do you know what module we're going to do?
she's so overweight. I'll be so embarrassed.
what about Carrie when you sit up there?
The module I'm showing there in the webcam there for slot 2.
And you don't have to stay with like
It's the OW16, 1769 OW16.
1769 OW16. Okay.
Yeah,
hold on.
it's on that paper that I had with the schematic. It's all on there. Yeah.
OW.
But until you've done this a bunch of times, it don't really get locked in until you've done it enough to get.
Right here. There it is.
That's it. And how hit create.
Yeah, that's the only problem I'm having right here.
Now you got to give it a name. You can just call it relay output, be fine. But that name could apply to some section of the machine that it's going to be controlling. It doesn't matter what you call it.
Okay.
It could be called cutter. It could be called pallet wrapper. It could be called pump, anything. And
I know this got to get changed.
You got to match it to the firmware revision of what module you have.
All right. Then
Yep.
hit OK.
That's fine.
Then create.
No.
Right?
You've already created.
Oh, okay. So
if
just
you hit create again, it's going to put another module in there.
Oh, okay.
You hit close.
So just close that out. All right.
Yeah, you've already created. Yeah.
I don't know why it won't close out. There it is. I see it. Dude. Okay. Now I should be able to do it now, right?
That's right.
New tag. Hand switch. And then go to alias.
That's right.
Then go here. Let me get that paper. I got the paper. I just got to get it to it.
Right. It's important for you to go by that document, because in real life you're going to be you've got to have a real schematic to go by on the wiring. You got to have that when you're writing your program. You have to decide. You got to decide on how you're going to wire it, input output, before you ever program it.
Right.
Because you're not going to have any addresses to go by. Yeah, that's it.
Hey, Mr. Durwood.
Yes, sir.
Okay, so I sent the first one I sent you. I messed up on it, so I sent you an updated one for the Sump Pump.
Okay.
Okay. I'm gonna let you help him while I work on this.
Right. Yeah. You're rolling now. Good. That's fine. You just keep trucking.
Thank you, Durwood.
You're welcome.
So is that to do the soap pump online or like on your actual PLC?
Yeah, you'll do it on the emulator first, and let me see it, and then you'll do it on the real PLC and email it to me.
So the name of it was supposed to be Latch, Unlatch, right?
No, Latch Unlatch is going to be after Sump Pump. That's another.
That's what I was thinking, and that's why I was a little bit confused.
The latch is what you do for those of you that are finished with the Sump Pump altogether. You can go ahead and start working on that latch program. You know.
Yeah, let me just rename that.
Yeah, that's just something to do for people like Kenneth that are ahead, or I'll say that are complete. They're staying caught up.
Well, trust me, I'm not exactly caught up in my other classes. So.
Right.
Yeah. I don't think I'm be working too much next week, so I can catch up with all my classes a mess, because I've gotten a little bit behind.
Okay. All right. So I'm gonna check the email real quick of Okay, so Dylan sent me another. Okay, so I've got that one saved. Well, you know, Dylan Shook sent me a program, but I don't see him. I don't see him in he's not in the session.
He may be at work or something.
Yeah. I know he's had internet trouble at home. He's had to move from where he was at. He's living in a different house, and he's had to change computers and everything. So anyway, I'm only going to check whoever's here, you know. So who's actually ready to show a circuit?
I mean, mine's ready. The one I sent you, so that's ready.
Just that Dylan Ivy?
Yes, sir.
Yeah, go ahead. Yeah, because whoever speaks up, we'll go to you first, you know.
Well, you got it.
That's right. You just give it to me. Ha ha. Okay. Lord have mercy. So let's go to.
Now I didn't put all those lights and stuff in there, but
No, I didn't ask you to do all. I just, you know, was just saying. You can add them. That's something you can do. You can add once we test this. You can add it and then send it back to me if you want to. So Dylan Ivy. Good. Okay, so you got your hand input, which is let me get my stuff here. Input 2 for hand. Stop is 0. Start is 1. And you want to change that output address because you're going to an EMCR instead of going to a starter that has an overload on it. On my trainer, if you look on the trainer, the first one is EMCR. We can run it that way. It's okay. We could just leave it alone. But the EMCR was one that was a plain relay that didn't have an overload on it.
okay. So you wanted the one with overload.
Yeah, output 1. If you look on the drawing that I sent you.
Okay. Yeah, I'm looking.
Yeah.
Let me look at the actual drawing. I didn't look
Yeah, the drawing shows you this output 1 that's actually got a starter with an overload relay on it. Yeah, I'm holding that up to the camera there.
Okay, let me go back.
Yeah.
Yeah, I can't see that on there. I pulled up. That's no problem. I'll redo it and send it to you.
Okay, that'll work. Okay. Who else is ready? Is Benjamin ready? Connor? Anybody have anything they can show?
I'm ready. I sent you my Sump Pump.
Okay.
I'm about to send mine.
Okay, so I'm gonna go to Connor's now. Go here.
So, Mr. Durwood, you wanted the one with output 1?
Uh-huh.
Okay.
Sent it to you in my email if you like.
Right, I got to go to the email first. Yeah.
We pull it up here, but I'm working on mine, so I'd have to close mine.
I think your sound, your audio kind of dropped out.
Oh, my bad.
Connor. Okay, I just saved Connor's. And McGill. Okay.
Just sent you mine.
I need to show you my emulator version as well.
Yeah. Yeah.
Okay,
Do
well,
do
I
the
had it on top.
the emulator first.
Okay, well, I can go do that right now. All right, let me get it pulled up real quick.
Okay, I see Jamie Jones. Yep. Do y'all see my screen?
Yeah.
The email. I'm getting Justin. That way you can see what I'm up to. You see me saving these programs and these files, these folders.
I always see is
And
your
right now.
Logic.
No, you don't. I'm gonna hit let's see, screen share,
I was screen sharing, I think.
email. Now, how about now? You see it?
Yeah. I resent that new update, so.
Okay. I just see them Benjamin.
Wood, is there any way, how do you rename a file after you've already saved it?
Save as.
Okay, I figured.
Instead of save as. You go under the file option, save as. I just saved Benjamin's. And then Dylan has just sent a new sump pump. It can't be because of the, hold on. Dylan Ivy, copy. Sometimes it won't let me do that, so I have to hit copy.
Well, it saved it in the file.
Copy and go back to there. Paste. The program's being used right now. I've got to actually shut the program down before it can copy over it. Close. And now I can go in there and copy over it. Yeah, you can't have it open if you got the project open. You can't copy over it because it's actually running. And that makes sense. It would be dangerous to do anything otherwise. So I saved Dylan's newest, Jamie's, Justin Sokolowski, and Benjamin. So I think I've saved everything that's came to me within the last few minutes. And I guess we'll go back to Dylan Ivy. I'm kind of lost track of who I was actually talking to.
You were going to do mine, I think.
Okay, well, okay, so let's do
It's
that.
fine. I mean, it don't matter.
Do we need to show you our
The emulator.
Yeah.
Yeah, I have my emulator pulled up. If you want me to start screen sharing.
All right, let me stop screen share. You go ahead and do your emulator. Can you enlarge it some?
I was just about to do that.
Yeah. Okay, go ahead.
What exactly did I do?
How do y'all like the software so far?
It's pretty good. I've gotten used to it now.
Do what?
I think I'm getting used to it. I'm
Yes,
able
sir.
to do it all right.
How did I even do that?
Still need some practice, of course.
There's a lot of guys that would love to know this stuff in these plants that ain't got access to it. It
Got
is.
the repetitive parts down.
Do what?
I've got the repetitive parts down.
Yep. Now toggle your float off. That's good. Now do the, go back to hand. I think I missed that.
I didn't do it.
Well, you got to do your stop button first. Yeah, do the stop button. Do it the way you would in real life. That stop has to be on first. And now toggle on, toggle off. Yep. And now toggle. No. Toggle off to start. No. You don't do it in that order. Think about it in real life. You got the start button on.
Now you release this.
Now you release. Yeah. Now you see your holding contact working.
Yeah.
Right. And then, if you hit stop, you would toggle it and then toggle again for it to be like real life.
Yeah, for it to be cap on.
For it to be just like it would be in motor controls, to be regular, a push and release to stop. Yeah, that makes it look like the real thing, That's good. So this is Connor's emulator.
Yes, sir.
Okay, let me go ahead and record that.
I'll have mine ready soon.
Okay, so what were you saying, Cameron?
I said I'm working on mine now, so it'll be done soon.
Okay, all right, that's good. And so Connor, while we're at it, you want to go ahead and let's see your real program run?
Yeah. You want me to show it to you on here, or do you want to go ahead and do it?
No, well, I've got to run it. We're going to run it on the PLC, yeah. Yeah, we're going to run. You tell me how to download it and run it. We're going to run it on the real thing here.
Okay. No, yeah. Go to
Okay, let's double check our addresses real quick before we download. So your hand is 2, that's good. Auto 3, stop is 0, start 1, output 1, 1, 6. And now you have green. You got green for running, and you got hand for yellow. You did basically like what Kenneth did for hand yellow and auto red. Okay. That looks good. Okay, tell me what to do on download and run.
Go to communication, active. Now go to your AP Ethernet. Now hit that mark. And now go to download.
Okay. All right. Now, you see my hand waving in the screen? So now we're going to go over here and check your HOA button, your switch. Hand, good, off, and auto. That's working fine. So in hand, we're going to hit our start button very briefly. There, let go. That's working perfect. We hit stop. It does that. Now I'm going to flip this switch over here over to auto. That's perfect. And now here goes the float. Floats is on, floats down, floats up, floats down. What do you think? Pretty good?
Yeah, looks good. Yeah.
Looking good, looking good. Perfect. Okay, you get a 100. And that's Connor on the real sump pump. Where's my, hold on. Well, I tell you what, I feel better about the class now that we're rolling, compared to the way I did about 6 weeks before it started. My stomach was in knots when they first told me what we were going to have to do. And I didn't know at that time that Rockwell was going to be as gracious as they are. And so, the Lord has blessed us with this, for sure. If it won't for this, I would be, feeling pretty bad about the class. Let's see. Connor.
I'm glad you did it because I wouldn't have got a chance to take it any other way.
Is that right?
Yeah.
You couldn't have done it in person?
I don't know if I could have done the hours with things with mama and stuff the way they are.
That's right, because you're rotating, taking care of your mother.
Yeah.
With your sister. Okay, yeah, that's right. And then Justin Sokolowski down in Jacksonville, he probably wouldn't have been able to do it either.
I've been trying to find one online for a little over a year now. So my advisor at ECU, he found out that you guys were doing it online, and he put me onto it. So I was pretty glad about it.
That's good. That's great. Well, I'm glad you got in. So that's great. That's great. I tell everybody that when you get through all of this stuff and you get that first job and get that big raise, you owe me a fish plate. Anybody ever heard that? Y'all have heard me say that?
Yeah, I've heard that one a few times.
Yeah, you've heard that a few times. So Justin, just one fish plate's all I'm asking for all of this, all this stuff that we're going through.
All right.
I'm just kidding. I've had two people to actually do it. Had Costa Ortiz did. He got me a fish plate, and let's see, Francisco Martinez. He's in charge of the PLC controls and drives at Turlington Lumber Mill now. They got a brand new PLC network in there. They got a lot of brand new drives and stuff. Allen Bradley 525 drives, and 5,000 controllers. He's working with this software now out there at Turlington Lumber Mill. It's running a whole wood planer plant. It's nice. He's doing good. So anyway, okay. So let's see. Let me make that note there. I made a note. You got Connor on the real Sump Pump. Okay. So now I'm gonna cut screen share off, and who speak up? Whoever else is ready.
Hey, Durwood, I got a question.
Yes, sir.
How was it that you changed like the normally open to normally closed again? Can't remember.
Click in the middle of the contact, and you'll see the 3-letter abbreviation, the mnemonic appear. Do the drop down, and then you would choose the one you want to go to and hit enter.
You said in the middle of the contact, that a right click or left click?
No, just double left click. You can do a screen share if you want to.
Okay. I'm clicking, it ain't working.
Yeah, do a screen share.
Yeah, I was sitting here doing this right here, and that's what I thought too. So that's better.
Now, you really, I would leave it alone, because in real life that's what it's going to have to be.
Okay, gotcha. Yeah,
what you have to do,
I started.
You'll need to toggle it. You need to toggle it initially, and that's going to give you the same conditions you would have on a real machine. It would be examine on.
So this will be fine for what we're doing.
Yeah, I would actually. My preference would be to leave it that way, because that's what you got to use in real life. You know.
Hey, I think I just remembered why it wouldn't let me do that. You reckon it could be that I'm in this mode?
Yeah, you're online.
Yeah,
you don't want to do those changes online. You want to go offline to make changes.
But it wouldn't even let me do it. So.
Right, because it would disrupt the machine.
Yeah. All right. Well, that solves that. Thank you.
You're welcome.
Well, actually, yeah.
Go ahead and run it. You go ahead and toggle your bits.
I'll go ahead and start that one. Now I reckon and start this one out.
Well, you want your switch is not on. You want to toggle that one.
So this one.
And then toggle that off. Toggle the start button off. So now they're showing you your holding contact function, and now that's good. And now you toggle that stop off, and then toggle the hand off. You get rid of hand, and got all the. And you got to. It takes you 2 steps to do what I do with one. If you look at my webcam here.
Yeah.
I've got a 3-position switch, and so, but I'm actually making moves like, I'm going hand is one move, And auto's another move. You see it in the webcam?
Yeah.
And you're having to do that by toggling one thing off and toggle another thing on. It's the same thing as me going click way over here and click way over there. You know, you're doing the same amount of work. You know. So now toggle your float on. Perfect. No, something's wrong. Again, no, you're good. Toggle the float back on. That's good.
Yeah, I was just toggling a couple times so you can see it work.
That's good. That looks good.
All right, so change your die in this. I think. Gotcha. Yeah.
You'll do the one with the real addresses now.
All right. Oh yeah, and I tried renaming it, and it just ended up saving it under it. So yeah, that's fine.
Hey, you want to look at mine, Mr. Durwood, when you get a chance?
Yeah, we're ready right now. Yep. So we're doing, let's see, for McGill, you had,
I just did mine right now, so I don't know. Might want to check it. I tried to run it on Emulator, but it wasn't letting me download. I don't know what I did wrong.
So which program are you on right now?
I'm on the Sump Pump. I sent you the other one.
You sent me the other one, okay? Right, for
Remember
basic, for basic logic. Look.
And I just did the Sump Pump right now.
On the emulator?
Oh, well, I haven't got to try it on the emulator yet, but I hit communications and then I tried to download it, but it wasn't letting me download.
Okay, do a screen share. Let's see what you got.
All right.
And then after that, we'll back up and look at your basic logic. Can you make everything a little larger? Yeah, if you can enlarge your program. Yeah. Okay, that's okay. And let's see about all your. Let's check your addresses. Now wait a minute.
I need to plug that laptop up.
That's not the emulator. That's the actual real one, McGill.
Oh, on the other one I got to put base, right?
Right, base tags.
Okay, I'll make another one then.
The one right there's got the real addresses. That's the one that you probably sent me already, right? That's the one that you sent me.
No, I haven't sent it to you yet.
Okay, that's the one. Let's look it over real quick and make sure it looks right, and then you send it to me. That's the one you're going to run over here
on yours, right?
That's right.
Okay, so on the other one, I'm not going to have any addresses. I'm just going to have base, right?
Base tags.
I'm going to run it on my emulator.
That's right. That's what we're doing first.
Okay, yeah, that was okay.
4 green light. That's good. Input 2 and 3. Output 5 and 6. Your program looks good. You can go ahead and send it to me. It looks fine.
Okay.
Yeah.
I'll just go ahead and y'all go ahead and continue, and I'll go ahead and write my base, and I'll let you see it on my emulator.
Okay, but look, while we're with you, let's go ahead and you sent me your basic logic program to run on the PLC. Let's go ahead and let's go ahead and check you on that while you're here. So if you can cut your screen share off. Okay. Now we're going to go back to here, and let's go. Right. Okay, let's go larger. Okay, so he got 3, 4, 5, output 0, 3, 4, 5, 1, 3, 4, 5, 2, input 3, 3, 4, 3, 4, 0, 1. That all looks good. Okay, so how do I download it, McGill?
Communications. Who active? And you hit on your Ethernet. Click on that. Yeah. Then you hit download.
You know what? I forgot to send Jordan Valentine a link, man. He was wanting to get involved. Hey, hold on just a second, guys.
Go ahead.
Let me send him an email right quick. I don't know why in the world I got a note wrote here and I forgot to do it. I'm just hold on. Let me hit stop share just for a second, and I've got to go to the get invite and hit copy link. Go to email and go to new. Okay, I'm sorry about that. I just he sent me a message. They said he did want to join the session, but I forgot to send him a link. He works for an engineering company in Mount Olive, is Goshen Engineering. He used to work at Smithfield Packing, and he's gone with an engineering company doing PLCs and drives and all, for doing it for plants as a contractor. And also, okay, so let's go back to out of here. I'm clicking too many buttons here. Share screen. There. Okay, so McGill, so we got your program in there now. And now let's check your input. So safety gate 1 and your thermostat, your OR circuit's working fine there with just that 1. Here comes gate 2. Do you see it? Do you see it running, McGill?
Yes, sir.
And then gate 3. And you can see me
Yes,
in the
sir.
webcam actually triggering the switch.
Yeah.
You know. You see all
Yeah,
that?
I'm looking at it. Yes, sir.
Okay. So if you drop out any one of them, then you're gonna lose it. You see it on the AND circuit, but on the OR circuit, all it takes is 1. You know, you have 1 there.
Okay. Yeah, I see.
1 there. So 1 thermostat gives you everything. I mean, gives you that fan.
Gives you the fan.
Because they're in parallel. They're OR. You know. So here on your combination and OR, if you get door switch 1 and get the thermostat, then the fan comes on. If door 1 opens and door 2 closes, then you're still good because you've got a door 1 or 2 plus thermostat gives you fan.
Okay.
Refrigerator door, if I trigger that one, it actually breaks the switch open, and then you lose the interior light, your courtesy light, by triggering it. Okay. And again, on that one, on that refrigerator door switch, if you have no voltage coming in, it's actually made the program. If I trigger the input with my external input, it puts voltage on that instruction and it makes it go to the opposite state.
Okay.
So anytime you see an examine off instruction, the only time it's going to be made like that is when there's no voltage coming in for that address, which means normal. Normal means what is it with no voltage coming in and it's normally closed. And then when you get voltage coming in, it toggles off. Okay. All right.
Okay.
And then on your NOR, if I toggle either one of them, you lose your light. And then on your vehicle, I close the driver door and close the passenger door, then your interior light goes off like it's supposed to. But if I open either one of the doors, then the interior light comes on. You know. Okay.
Okay.
Good. And then your memory logic, you get your start, and then I let go, and it's running around. Your holding contact's got it now.
Okay.
Okay. And I hit stop, and then it resets it. You're ready for another. You're ready for another run.
Yeah.
Yeah. That's it. Okay.
Okay.
Let me record your grade there. That's got you. That's good. Now, I haven't checked yet, McGill, to know if you had actually done the questions for this logic.
That's the first one, right?
Yeah.
I haven't done that. I think I didn't do it, but I did the chapter 1.
Right. So that's one you can go back over the weekend. Go back over the weekend and check everything in Moodle and make sure that you can go back to the earliest stuff and make sure that you're not leaving something off. Because I haven't checked. I haven't checked during the week. I did grading the weekend. I hadn't graded any since then. To know who's done what.
Yeah, I'll do that this weekend.
Okay, good.
Hey, Durwood.
Yes, sir.
I ran into another problem.
Uh-huh.
All right, I'm going to share my screen. Hold on.
Okay.
You see what I got come up when I try to download it?
Uh-huh.
What in the world going on now?
You tell me what's wrong. Read that message there.
It says controller slot specified in project file does not match connected controller slot number.
Okay, so you're trying to download to the emulator, right?
Yeah. So
okay.
I can send it to you.
Well, it looks to me like what you're doing here is you're trying to download a real PLC program to the emulator.
Okay.
And it's not going to accept it.
Oh.
Let's look at the program that you have up top. That's not an emulator program that you're looking at. You got real addresses.
No, yeah,
there.
this is the real address one. Yeah. So what am I supposed to do now?
You can't put that in the emulator. It won't take it.
Oh, so all I do is send that to you then?
You send that to me.
Oh, man, see, I fell asleep the other night. I must have.
The emulator won't run on real addresses. It won't.
All right, I don't know what I'm thinking.
Yeah.
For some reason, I'm getting confused here tonight.
Well, it's okay. You're learning. You're still doing real good. It doesn't matter if you mess up some. You're gaining. You keep learning. You're doing good. So
All right, I'll send this to you then.
Mr. King.
There's a lot to this stuff that you guys are trying to do here. It's a lot to it. Just give yourself some wiggle room there. It's okay to mess up. It's actually better to mess up with the emulator than it is to be doing it in the shop and something go wrong.
Oh yeah, I totally agree with that.
Yeah.
Hey, Mr. King.
Yeah.
I did kind of the same thing as him, but mine was more out of laziness. I was just trying to change the tags to run in the emulator, and now I've got it where I can't even get back to my actual inputs and outputs. We'll see if you can
do a screenshot. Let's see what you got. It won't be much to fix it.
See, now I got everything with question marks.
Okay, so let's see your project name. This is going to be for a real PLC.
It was.
No, it says emulator up top.
Yeah, somehow it's got on that.
You got to change your processor by going to the top of your organizer.
Okay.
Where it says controller J Sokolowski. Sump Pump. Right click there and hit property of the controller.
Okay.
And now you sitting there with an emulate controller. You got to change that controller.
Okay.
If you're going to do the real one, are you trying to do the real one or the emulate?
I sent you the real one, but I was trying to be lazy and not have to remake it to do the emulator, and then I jacked it all up in doing that.
Well, you can actually go in and modify it like you're doing now. You can do that.
Okay.
But have I seen the emulator run yet?
No, that's what I was trying to do, because I sent it to you, and then you said you want to see the emulator first, so I was just trying to take what I already had made and show it to you real quick.
What you can do. Well, I mean, we got to figure out first. Do you want to? Well, what did you email me? Did you email me the emulator?
No, I emailed you the real thing.
The real thing?
Yes, sir.
Okay. And so tell me what happened here, though. If you email me the real thing with all the addresses in it, What led you to do what you're doing now, though?
Because after I emailed it, you said you wanted to see it run on the emulator first. So I was trying to take this I already had open and make it run on the emulator without having to rename everything.
Oh yeah, you can. Oh yeah, you absolutely can. Yeah.
And then I ended up with all these question marks because if I double
Right. You got to go back and change those tags to base tags. They can't be alias tags anymore.
So I do have to do it one at a time?
Yeah.
Okay.
Yeah.
When I went in here, I still have I don't know, I got it all jacked up here.
Well, but basically, look, try to right click on one of them.
Okay.
And hit edit. And now that you go in there and change them like that, yeah.
Okay.
Yeah, that's it. The data type could not be found, invalid. So hit OK. So the type of tag, base, data type. Well, the data type is going to be BOOL for Boolean. Somehow you change that. That's for single bits. You hit apply.
Okay.
That's fine. The data type is going to be single bit, which is bool, BOOL, and you shouldn't have to be messing with the data type.
Yeah, it's all. I hadn't clicked it before, but it just kind of erased everything on me. Because I just went in and changed the.
Yeah. On the next tag, go kind of slower. Let me see. You shouldn't be having to do that at all. Ho. On the data type, you should not be having to specify that because by default it's going to be a bool data type, which is a single bit. You shouldn't be having to change. Just put your type up there for tag type. Make it base. And now hit apply. Failed to modify properties. The data type could not be found, or the format is invalid. So it looks like when you're converting from a real PLC program back to emulator, you're going to have to tell it bool.
Go back to bool, yeah. Because
you're going to have to go. I've never seen anybody kind of go backwards, go from
real to emulator.
I've never tried to go real to emulator, so this is just something new. But that's what you're going to have to do if you're going to do it that way.
Okay.
Yeah.
Alrighty.
So now you got to work twice as hard.
Yeah, I was trying to be slick and
right.
Just make it.
Yeah, I know what you're saying.
I thought about it too, but I was like, it'd probably be more work.
Well, you can go from emulator to real within the same project and it not be a big deal. But going backwards like that is going to be a big deal. You know, you can do it now, but it's going to be more to it than it.
So would you just have to go through and like change the tags to like alias or something?
Yeah, if you had the emulate version, the first thing you would do is go in there and change your controller from an emulate controller to Compact Logix, and then once you save that, then you got to go out and change your tags from base to alias. Yeah, exactly.
And then you just input the output and inputs, right?
Yeah, you would choose those addresses. Yeah.
I reckon I'll try that next Sunday.
Yeah. Mm-hmm. Okay. So I think Justin is he's working on his getting his tags fixed and all. Anybody else ready?
I'm ready. I emailed you mine, and I've got my other one pulled up too.
You got your emulate pulled up?
Yeah, I've got the emulator pulled up, and I just emailed both of them to you just a few minutes ago.
Okay, go ahead and show me the emulator, and then I'll run your real one.
All right.
After him, we can do my basic logic function if you want to, since I missed it last week. I mean, Tuesday.
Who was that was talking?
It's Jameson. Can you hear me?
Jameson?
Yeah.
Okay. Sound like you're kind of distant from your microphone, though.
It is.
Okay, I see that. That's good. No, you got to hit download first. Yeah. If you go online, you're not. It's not gonna. You got to download it first. Yeah.
Hey, Durwood, I think I just sent you mine.
Okay. Just remind me when I get in looking at his stuff here. I don't want to be zigzagging in and out of stuff much.
Yeah. That's fine.
The later it gets, the worse I'll get. If I start doing that, I'll get all fragmented and everything. Okay, so you got your, and you can hit Control T once you highlight them.
That's good. Now I'm like I'm hitting the start button.
Right there, and now toggle that off. Yeah, that's good. And yeah,
I forgot to add the module.
Okay. Now you want to cut the hand switch off, because look on the real thing. If you look at my webcam, you know when you're going. You know, you got to go. It takes 2 moves to make that happen.
Yeah.
Perfect. That's it. Now toggle the float off. That's it. Okay. So that's Cameron on the emulator sump pump.
All right, I got it when you're ready.
Who is that talking?
Justin.
That's Justin. Okay. Now hold on. I think while I've got Cameron here, we're gonna go ahead and check his real one. Since I'm talking with Cameron right now, let me get him. And that way I'm kind of we get one person took care of while I'm So, have we opened your email yet, Cameron? I don't remember.
I don't think you have.
Cameron Pump Logic.
It'll be
now the emulator. I don't need the emulator because I've already seen you run that.
Yeah. I think I sent them both to you. But one of them on the end has emulate, and the other one is compact.
That's right. That's right. And then let's see. Victor just sent one. Go back while I'm in the email to go ahead and save them.
All right.
Okay, and who else might have sent another one? Eric?
Yes, sir.
Save as. Eric, are you surprising yourself what you're learning so far?
Yes, sir, I am.
Are you proud of yourself?
I'm very proud of myself.
That's what I thought. I think are you plumb amazed at what you're doing?
Yeah, I really am. I mean,
I know you are.
I'm starting to brag about it to Justin.
Yeah.
You ain't the only one that's amazed.
You a traitor right now. Get back to Newton Grove.
Lord have mercy.
He traded on us, Durwood. He back in Newton Grove for this week.
Who? Jamie is?
Yeah, he traded up on us.
They must have had something bad go on. They had to pull them back, huh?
Nah, he has a project to do for the new building.
All right, so here. Let's real quick. Right, let's go. We were on Cameron, and so let's go here.
Oh yeah, the
Sump Pump. Okay, input 2 and 3 and 0 and 1, output 1, 1, 4, 2 and 3, 5 and 6. Okay, so how do we download?
communications, active, and the AP Ethernet. get it downloaded. Download again.
Okay. Now HOA switch. Hand is good. You see it running? Aldo, do you see the screen? Can you see it, Cameron?
Yeah, I can see it up there.
Okay, so it goes hand, and now it goes start, let go. That's good. Stop. We're gonna go back to auto, and then here goes the float. Floats on, floats off, floats up, floats down.
Oh yeah.
That's good. And let's see, back to hand, and your red light's working in auto, and your yellow light's working in hand. That's good. So everything's good. Great. Let me record that. That's a 100. So that's Cameron. Okay, that looks good. And I think Justin Sokolowski, we had an issue with yours. Let's jump back to yours.
Okay.
Now what was it we were going to do? We were looking at the real one.
I had to switch everything over to run on the emulator so you can see it.
Right. So go ahead and let me cut my screen share off.
So here's mine.
Right.
Then
yeah, if you can kind of enlarge everything a little bit, it's hard to see.
Can you not? Can you do that?
It's kind of small. Go over, hit your magnifier. It's on your toolbar. Yeah. That's better right there. Yeah, and I don't have to strain to look at it. Okay. Right. And once you highlight one, you can hit Control T and it'll toggle, you know.
Okay.
Or you can right click, whichever. Now toggle your start button off. The start, the start, yeah. That's the one that would be open right now that shows you have your alternate path there with your holding contact running. Gotcha. That's good. Okay. Now just go to your hand and cut your hand off. You can leave that stop like it is, because that stop's gonna be made, you know, when you let go of it.
Gotcha.
And then you go to auto now. Hit auto. Okay, good. And now do your float. Good. Now toggle the float off. That's good. And yeah. Now, when you did your hand, did it make that yellow light go on in your program? Yes. It did. I see that. Yeah. I see that you used the same tags. That was good. Okay, great. So let me record that.
Okay.
So this is that's your emulator on Sump Pump. That's good. And then now let's go to your real program. Okay, and so what I've got here, Justin, it doesn't have any addresses in it.
Man, come on. I guess I sent you the. See, I sent that before I started messing with it, so I don't know how.
Let me go back to the email and see if there's
Oh, man.
Do you think that this was the last one you sent, or was there an earlier one maybe?
I only sent one. I only sent it once.
You only sent it once?
Yes, sir.
But listen, you showed me a program that had real addresses in it a while ago.
Correct.
I'm gonna cut screen share off. Let's see. Do a screen share and let's find the one that you do. I think you've already got one that's ready to run.
Okay. Get to my logic here. Okay.
You have to go under your open folder. You'll go up top to open. Yeah, and so you should have one of those in there. Should be the one with the real address. You can just try them. You can open one up and try them, and I think you'll find one that'll have it. Yeah, right there. Yeah. Let's double check the address is real good. If you can enlarge it. Okay, that's 2 and 3, 0, 1, output 1, 1, 4, 3, 6. That's good. Yeah, send me that one. So that's going to be BAK002. It's your backup version number 2. That's good.
All right, I'm sending that to you right now.
Yep. Now see, the software saves. It'll save like, I think it might save like 5 or so, if I'm not mistaken. Something like that.
I think it was up to 6 because I had too many the other night. I think it stopped me at 6.
Okay. Yep. But that's a good thing that it's going to save the last few versions that you did, so you can revert back if you need to.
Okay, I just sent you that version there.
Okay.
The email title Sump Pump 2.
Okay. Let's see. Share screen here. Hold on, where are we at? Let's go out of there. Go to here. Save as. That's good. And let's go back to there. Stop share. Share. There and go here. There. Okay, now we got the right thing now. This is amazing that you could be way down in Jacksonville and you sent it that quick. Ain't that amazing? It is amazing that we're doing what we're doing. It's amazing. It really is a blessing. It sure is. If it weren't for being able to use Zoom and having Studio 5000, I would be a very discouraged instructor. I would be upset. I would really be upset because it would be nothing but Moodle, you know.
Yeah.
And me and Ruben call it oodles and moodles, and all you'd have was oodles and moodles and no meat, you know. That's all you'd have. You'd be eating oodles and moodles.
That's why I always hate online classes, because all they do is give you work and don't teach.
Right. Well, I can't stand that. I cannot stand it. I said, man, I can't stand the thoughts of that. I said, when Marion Pope said that she's going to show us how to use Zoom, I just about run over there. I said, I've got to see this, you know. And when I saw that, I said, we're going to be all right, fellas. We're going to be all right. So it ain't like being there, but it's you know, it's pretty darn good though, you know. Right, so,
Hey, Mr. Durwood.
Yes, sir.
When you get a chance, can you I was trying to download my emulator to my trying to download it to my emulator, but it's saying something about my module for my block.
Okay, listen. I'm gonna cut my screen share off real quick here, Justin. I'll be right back to you.
Okay.
Do a screen share, McGill.
I hit right here, right? And then I hit download.
Right. Look, read the message to me. Tell me what it says.
Fails to go online with controller or controller slot specified in project file does not match connected controller slot number.
Okay, so now hit OK. And now look, now X out of that screen. Now go back over to where it says controller M Salinas Sump Pump. And right click. Hit properties. And now look at the slot number. You have slot 0. It's got to be slot 2. No, not that. You got to change the slot number. Look, the slot number. Slot number. Yeah, that's it.
It's not letting me click on it.
It's not.
He's got to change the controller type, Mr. Durwood.
Who did it?
Oh, that's right. Look, if that's going to be for emulator, it's got to be an emulator processor.
Who did it? Why would I do it?
So
Raise your hand if you did it.
do the drop down there.
Raise your hand if you put Forky in the
Which one?
No. Change controller.
No, get on that.
Now do the drop down. The drop down there. You got to go way down at the bottom and choose the emulate controller. I didn't realize that you had an actual real controller in there. Victor saw that, I believe.
So what now?
I think Victor saw that.
Yeah.
That one right there. That's it, yeah. When you're going to the emulator, it has to be an emulate controller. It can't be, you can't put a real PLC in the emulator. It's like I can't eat an elephant.
Throw it off. I mean,
it's like I can't eat an elephant. You're trying to give it an elephant, but it can't eat the whole thing.
Try.
It can't though.
One bite at a time.
Yeah.
All right. Okay. I'm gonna go ahead and try it now.
Whoa! No, you're still not ready. It's got to be a slot 2. Your slot number won't right.
Okay. All right. Let me go back.
Right. There you go. That's it. That's it.
All right. Okay.
Yeah. And I tell you, I think that the number of slots in there was supposed to be 10, I believe. No, you got a 17 slot chassis. You're fine. Okay. That's fine.
All right.
Okay.
I'm gonna go. All right. I'm just gonna go ahead and download it then. Yeah, I'm going to continue. Thanks.
You want to go ahead and down? Okay, so you've gone off. So, all right.
Hey,
While
go ahead.
Did you want to go ahead? You want to go ahead and show it while you're at it, McGill?
I can if I'm not at. It won't take long.
You might as well while we're at it, you know, well,
All right, so
you can do it.
Yeah, toggle your bits on. Yep.
Okay, don't matter. Whoever did it.
Whoever did it, clean it up. Whoever did it, fix it. and quit crying. Quit crying and just fix it. Quit that crying. Y'all hush up.
Honey?
I'm trying to teach class. Quit crying.
Nobody talk.
What do you think?
Hold on a minute. You got to do leave the stop button on. Now cut the start button off. There. Now that's the way it would be done. There, you would release the start button and it would run around there like that. That's good. Now cut the hand off. You can leave everything else on. Just cut the hand off. All right. Now cut auto on. And now do your float switch. Okay. Now cut the float off. That's it. That's great.
All right, I'll go ahead and send everything to you right now.
Okay, now I'll go ahead and record you now, then we'll get back to Justin. So that's McGill on Emulator for Sump Pump.
And then I'm gonna send you the one with the address on it too.
Okay, good. All right.
All right.
Okay, so sorry, Justin. We're back to Justin to Okay, now we're ready now to download yours, right?
Yes.
Do you see your program?
Yes.
Sorry about that. Sometimes it just kind of pays to go ahead and help somebody that's stuck, And,
oh yeah.
And kind of keep moving. I'm trying to move along better. Kenneth, am I moving better tonight? he may be gone. He said, I wish the class could go twice as fast. And I said, well, I'll try to do a little faster.
No,
I'm kind of a turtle. I'm kind of a turtle by nature, man. So I can't go too fast. I start screwing up if I go too fast anyway.
Yeah, I need to slow down a little bit myself.
Yeah, that's okay. But it was kind of draggy the other night. I do need to pick it up some. So what do we do here, Justin, about getting it downloaded?
Go to communications, who active, then click on your Ethernet port there, and then click download.
Well, you got to actually highlight that IP address for the controller before this even shows up over here.
Okay.
Yeah. So if you don't point to the actual IP address or the port on the controller, then your options are grayed out until you specify which IP port. Okay, so I'm going to check the switch. We're going to hand. Hand's good. And auto is good. Good. So back to hand. We're going to try start. Start and let go. That's perfect. Hit stop. Perfect. Go to auto. And here goes your float. Float's down. Float's going up. Float down. And float up. Y'all see it in the webcam me moving the float?
Yes, sir.
This is working out good for you to see the camera plus the logic. And this is about as close as you're going to get. I mean, this is the real thing. What you're seeing is the real thing. The only difference is we're in two different places, and you didn't physically wire it, but you saw how I wired it. So I would bet money that any of you could wire it now that you've seen the wiring, and you've seen me trace through it. You could do it in very quickly, So that's the only thing you're missing is just physically getting to cut the wire and connect them, So this is still a lot better than what it could have been if it was nothing but Moodle. I would really be upset. But okay, that's good. So I'm gonna put you down. That's 100 there, Justin, on the real McCoy. Let's see. And for those of you that are checking in Moodle on your grades, you'll see more grades being shown up the weekend as I get them entered in. I'm doing them on a paper spreadsheet now. I'm still old school enough to where I know to keep up with things on paper, because if you get a situation where you can't get, if the internet goes bad for the school for a while, then I've still got a paper copy to keep up with of grades. And that's just my thing. I'm going to do that. You're not going to see me. I don't think you're going to see me go completely paperless. I'm not comfortable with that. So,
well, no, I'm fine with y'all not putting in grades. Every time I look in there and say 100, I feel real good.
Okay, so who?
I just sent you mine.
You just sent one?
Took me a minute to upload it to the email.
You still got mine too. I sent you.
I was gonna go ahead and download that book offline, but I think I need to set up an Amazon account or something. I don't know. I think I need to connect the card to it.
Okay, just save Rogers, and then who else said they sent something?
Me.
Eric.
Victor.
Yeah,
Victor.
yeah, I sent mine, but I think you got it already saved.
Yeah, I think I saved Victor's. I believe I did. Yeah, I know I did. Unless you sent two. No, you've only sent one.
Yeah.
Okay.
Hey, what about the latch and unlatch? Do you want physical addresses or you just want the emulator?
You can do both. Do the emulator so you can run it yourself.
I
and let
already
me
did.
see it, and then do real addresses.
All right,
But for the real addresses for your unlatch, it's going to be a new address of input 7. So for latch, it's going to be, you use the regular start input, which will be input 1 for latch, and for unlatch, it's going to be a new address of input 7. I've got to physically wire. If you look on my webcam, let me cut off. You see my hand moving around?
Yeah.
Now, the green button right there, the top one's going to be latch, and the second green is going to be unlatch. I'm sorry. Wait a minute. No, I just told you wrong. That one right there is actually input 1. That's going to be latch. I want to have latch on top. So I guess what I'll do, you could just say, it doesn't matter. We can say that be latch and that's unlatch. Let's just leave it that way. So latch is going to be the normal start button right there, and which will be input 1, and your unlatch is going to be input 7, which is the next spare input after the float. Instead of me having to move everything around, on that drawing, you see that drawing there? The next available input is going to be input 7. So I'm just going to let that be the extra momentary button that we're going to use for unlatch. I don't like having addresses scattered that way, but I don't want to go changing all these other addresses of these switches in here, because there are still students that haven't even done the first lab yet, that are not logged on the night, that haven't done any programming, haven't showed me any programming that's completed yet. None.
Well, I don't want to rush it. Just whenever you feel like you know where you want it at, I guess just send it an email, I guess.
Right. Well, just basically all you got to do. Listen, for latch, it's going to be input 1. Unlatch is going to be input 7.
All right.
And then your output, let your output be output 1.
All right.
And then as far as the lights go, you can use the lights on there, and you can let green be latched and red be unlatched.
All right.
And you can go from that, and I mean that's simple enough, isn't it?
Yeah.
Yeah. Okay. And just remember, let me just show you something real quick here before you go write the real one. It's when you go to hold on. Let's go to screen share and go here. Now, do you see the logic screen there?
Yeah.
Now, up here, you see where I'm pointing on the output energize?
Yeah, you got to click the U or the L on latch.
The L is for latch and the U is for unlatch. So y'all pay attention there. That's a standard output energize there. This is L for latch output and unlatch output. And these are on the next lab. That what latch does is when you latch an output, it stays on even when the power goes off. When the power goes off and the power comes back on, that latch output comes right back on. It's called retentive. So retentive means this, is it remembers the state that you left it in even when the power goes off. So if you get a power glitch at the plant and the power comes back on, a latch instruction will actually boot up and it'll turn itself right back on for critical things that have to be turned back on by themselves. That it'd be too much of a time lag for somebody to go do it. That they won't. I mean, some things are using latch instructions that are retentive through a power outage. As long as your lithium battery is good in your PLC, that latch instruction will stay on even through a power outage. So anyway, and now I've lost track of who. Victor, you were saying
Well, I was just talking about the latch and unlatch. I mean, you can go ahead with another student.
Okay. Yeah. Let's try to get people caught up on what on the stuff that are not caught up on.
All right.
So how about Benjamin or Jamie? Justin Sessoms. I see Justin coming in, but I hadn't heard nothing out of you.
I got my emulator pulled up if you want to look at it.
Okay, that's fine. Go ahead.
All right, let me let's see. I think that's it. Yeah, that's it.
That's good.
Let's see.
Now cut your hand off. You want to cut the hand off and then go to auto, like it would be in real life.
Yeah.
There you go. Yeah, because when you flip that 3-position switch, it's going to cut one of them off before the other one goes on. That's it. Good. Perfect. That's it.
All
okay,
right.
So that's Jamie.
Yes, sir.
On emulator.
Yeah.
That's good.
You should have my other program.
Okay, so let's go back to the yeah. So there you go. Screen share Logix. And okay, Jamie Jones and Sump Pump. This is amazing me what we're able to do. It's a blessing. I ain't kidding. It's just amazing.
It's real. It's a lot more detailed than I was expecting it to be. But I'm gonna tell you what, they got this program together.
They do. It is. I'm telling you, man. You guys, seriously, you listen to me good here now. What you got in your hands right now is about a $3,500 package at least. I hadn't priced it lately, but several years ago, if you bought that one package standalone, it was around $3,500. It may be more than that now. And I don't know what the emulator costs. I think emulator probably come with it automatic, but what you're working on right now is the newest thing out with Rockwell, and that's what I don't care what plant you go in. If you're using Allen Bradley controls, and they got newer controls, then they're using this same package that you're working with right now.
I got a quick question.
You go in Smithfield Packing, you go in Butterball, you go anywhere you want to. It's got Allen Bradley controls. And if they got newer controllers, then they're using this software. And most places are going with newer stuff. They're phasing out the older 500 stuff gradually. So eventually that stuff won't be used, you know. Yeah. Go ahead, you had a question?
Yeah, if you just wanted to like mess around with like and practice at your house or whatever, like is there any like other software you can use? Have they got like a free version or anything like that?
Your audio was cutting in and out. Say it again.
Do they have like a free trial version or something like that where you could mess around with it at your house? Or do you not know?
Of this same thing?
Or something similar to it, you know?
You mean like after your trial period ends?
Yeah, I was just wondering. I mean, probably wouldn't, but I was just curious.
I'd have to check on it. I know a couple of years ago they were letting people. There was a simplified version of RS Logix 500 that they were called RS Logix Lite or something like that. There was like a scaled down version, but it wouldn't be for this platform of Logix 5000 controllers. It wouldn't be for this. But see, this software is always going to be on your computer. It's always going to be on there. It's not going to go away. But what it is, it's simply after you have 90 days of runtime with it. Now, that's not 90 calendar days. It's 90. What I've seen before on expiration is when it told me that I had 7 days left before I had to renew, it could have went on a couple of weeks. And what I took from that was that it's actually counting the hours you're running, not the calendar days, you know. So this software is not going to go out anytime soon for you. And unless you work with it a lot, it may not go out. You may not see it go out, you know. Depends on how much you mess with it. When you hit another semester, you're going to be on other things, you know. Yeah. And so it depends on how much you work with it. You'd have to work with it a lot to really use up this 90 days. You'd have to work with it a lot.
Gotcha.
Yeah.
Well, thank you anyway.
Yeah, you're welcome. And all it would take to ever renew it would be either for you or an employer to pay for the activation fee to reactivate it again, and it would come, and then it would be activated again just by putting in a serial number and a product key. You know,
gotcha.
It would be just that simple. Somebody had to pay the fee to renew it, and then you just put that information in, and it's going to start running again. You know, so this stuff is not going to go away. You know, you got it, and again, it could be turned back on later on if you ever see it cut off, and you may never see it cut off because again, you may not use it enough to even use up all that time. You know, it all depends on how interested you are in it. You know, so because say in the fall you're going to be taking other classes, and you may or may not start working with this stuff again at that point. If you do, that's good, and I hope you do. But your next time using this stuff would be in January when we do it in person at the school in the ELC 215 class on the actual automation system that's out there, the physical system. So, okay. So this is Jamie Jones, and let's see, that's 2301 output. Okay, so you've got the output there for the MCR relay instead of for the starter, but it's okay. Let's go ahead and run it for the sake of time.
Hold on a minute.
3, 6. It's okay. We'll run it that way. That way we can keep on clicking.
Put data 1 on there, shouldn't I?
Yeah.
Okay, I see what I did.
That's okay. Let's just run it because I mean you see what happened.
Yeah.
Yeah. That way we can let's try to cover everybody. Because some folks I really hadn't seen anything from some people in the group or not. So, how do I download?
Communications. Who active? To go to Ethernet. Highlight it. Download it.
What, you're back over there with Travis now, ain't you?
Yeah, for a few days.
Right. You can show him. I wish you would show him what you're doing, and he'll be impressed with it. I believe.
Oh yeah.
He will. I think he'll be very surprised. Okay. So that goes hand, auto, and with hand there goes your start. That's perfect. Stop. Go back to hand to auto, and then here goes your float. Floats down, floats up, floats down. You see the float going?
Yep.
Okay, so you see in the webcam too?
Yes, sir.
Great. So this is almost like being in person with it, isn't it?
Yeah.
It's almost. It's the next best thing to it, man. So that's great. Okay. Let me put you 100 down. Let's see. Let's see. Jamie. That's good. Okay. Who else?
Got
I
mine.
sent you mine already.
I sent you mine.
Okay, so I think the first person that spoke up was Eric.
Yes, sir.
Okay, so let's go. Let's go here, Eric. Sump Pump Logic. Good. Yeah, this is amazing what we can do, and as fast as we're doing it, it's what you call remarkable, you know. We markable. You remember the Little Rascals? That little boy that would say "we markable." He said "we markable." How many of you know who the Little Rascals are?
Yeah, I remember them from when I was little.
You know that boy that would say "we markable." I don't know if you remember that one or not. One of them boys, I don't remember his name. It won't Spanky or Stymie or Alfalfa. It was one of them. He was real quiet. He said remarkable. He broke it up. Remarkable. Okay. So this is Eric, and we're going to go hand. No, we got the download first, don't we?
Yes, sir.
All right.
Go to communications. Who active? Ethernet. Highlight your download.
Now, there goes your hand switch. Good. Auto, that's good. That's your lights also. And now in hand, we'll go start. Perfect. And then stop. Perfect. Go to auto. And here goes your float. Down, up, down. See it?
Yes, sir.
Perfect. Remarkable. 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 Okay. So that's
making
Eric.
Jamie proud.
Right. There you go.
I think that's a little bit of an overreach there.
Hey, come on now. Give me some credit here, Jamie.
Okay. Who had spoke up next? There was somebody else that y'all were talking on. Who?
I sent you mine.
I can go first if you want to.
Y'all tell me who.
I can go first. I'm by
Okay,
next.
that Benjamin.
Yeah, you already saved mine.
Okay, I saved yours. Okay, let's go back to there. Yeah, you were mighty quiet there for a while, Benjamin. I was wondering what was going on there.
I was just listening, trying to get everything.
You taking it all in?
Yes, sir.
Good. Yeah. You're coming in, Benjamin, sort of in the high end of things. In the fall, you'll learn about introduction to electricity. It's gonna you're going to start to fill in some gaps on some things that you probably got questions about, you know, in the fall, in August, when if you take intro to electricity and residential, if that's the starting point, was the best starting point there. So you're kind of going in, like I've seen someone else come in to start at PLC and then go the other way, you know. So
well, I started with, I didn't take it, but I wish I did. But I was going. Well, it was so late in the evenings whenever it was scheduled, I couldn't take it, and now it's going to be like the second to the last electrical class I take.
Yep.
Yeah.
Oh, okay. So there goes our hand switch. If you notice it, no, we ain't downloaded yet. So we got, how do we download, Benjamin?
Communications. Proactive. AB Internet. That one below it. And download.
Okay. I think y'all know how to download. Now, upload something that we've not been doing now. When you're downloading, you're sending a copy from your laptop to the controller, to the PLC. So what do you think upload would be?
Getting a copy of the instructions from the PLC to your laptop.
That's right. You're copying from the PLC back up to the laptop upstream. Upstream is back up to you. So that could come in to where if you didn't have an offline copy of a program in a plant and you wanted to get a copy to save, maybe somebody sent you a machine from another plant and they sent you the machine, but they didn't send you a copy of the program, but it was in the PLC. So you could connect to the PLC and set your communication up, and then upload the program to your laptop and save it, and then you've got a backup copy. If the PLC happens to go out, then you've got a backup copy, and you need it. You seriously need that for everything in your plant. And you want to back up on a laptop plus a backup in some other form that's not in the laptop. Like I prefer burning them to CDs. So if you have some way of burning them to a CD, do that, or at least put them on an external hard drive that can be stored somewhere in your maintenance office or your engineering office, that you've got more than one backup source of all of your programs in the plant. So, okay. All right, so go to hand, that's good. And then auto, that's good, that's good. I see your lights. So in hand, we're gonna press start. Very good, let off, that's good. So the green light come on, that's great. Hit stop, perfect. Go to auto. And now the float is down and now the float is up, perfect. Down, up, down. You see that in the camera there, Benjamin? That float I'm moving? That float would be dangling. It would be like that in a water tank or waste treatment pit. And when the water rises up, you know, it's going to make that thing flip over like that. And that's what runs it. So the actual liquid level in the pit or the tank is what's going to run that. Yep. And they use sump controls in basements of houses. They use them in boats, like on the ocean. If you go out on a boat, they'll have like a pump, a float that if you get too much water in the boat, it'll actually pump water out of the boat, you know. So I think they call it a bilge pump. Is that right, Connor? Or any of you that know about boats, do they call it a bilge pump? But anyway, you could.
Durwood is called a bilge pump.
A bilge pump.
Yes, sir.
That's what I thought. Yeah, but it's the same principle. It's got a float in it, and if you take in too much water in the boat, it's going to pump it out when the float turns on. So, so anyway, so Benjamin, you good to go there? Let me record the grade. Let's see. Now, Benjamin, did you do your emulator with this?
Not yet.
Okay, so you can do that, and I would encourage you to do it, so you can have it and actually make it run yourself by your own hands. You know what I mean?
Mm-hmm.
Okay, so just at whatever convenient time that you have to do it, you can do it. And so let's see. Now let's cut this off. That you did a good job on. You're catching on fast, man. I knew you would. Who else do we have? How about Victor?
Yes, sir.
So let's see what did we. Okay, your actual the real program. I haven't seen yours run yet, but I think you just sent it to me.
Yeah.
Okay, let's go to Victor. Well, how you feeling, Victor, about the whole thing?
Pretty good.
Yes, sir. Yes, sir. You're doing a mighty fine job, man. You're gaining on it.
Yeah, I got a little setup at the shop, though. I keep entertained.
Yes, sir. Have you showed anybody?
Yeah, I showed my superintendents.
What does he think?
Pretty cool. He was asking me how much is it to keep the software. Just question.
Right. I'm not sure what it would cost. You guys would have to go for them to do it. They'd have to go through McNaughton. Yeah, McNaughton McKay is the regional distributor out of Fayetteville. So our representative for this area would be in Fayetteville at McNaughton McKay, and they would have to go with their industry price, whatever that is. It's not cheap, but
we're depending on you.
but I can tell you right now, if he's already asked you that, then in the back of his mind, he's looking at maybe paying for that to get renewed so you can keep it probably.
I mean, either that or we're gonna get a new laptop for the shop. So
right,
I don't know what he's gonna do. To be honest with you.
Well, it'd be nice if you could have it and be able to take it back and forth working home, you know.
Yeah.
And it stay active, you know.
I guess before you leave the class, when you get a new laptop, go ahead and hit on that one first, right?
Yeah.
So does he seem happy that you're doing this?
Yeah, like I said, I hooked up to a PLC, kind of the same one you got.
Yep.
Job, we were just messing around with writing small stuff. He's pretty good at it too.
Who is?
My superintendent.
Good.
Yeah.
That's good. So does he seem surprised? Do you see any surprised look on his face?
Well, he's a very tough man. So,
I mean, does he seem surprised that you're where you are now?
Yeah, he is.
Yeah, I figured he would be. Everybody I know in the industry, did I tell what we're able to do right now? They are very surprised. Like Jordan Valentine's very surprised that Rockwell's letting us use it and that we're able to do what we're doing. And especially with this many people, it's very, very good, very good. A blessing. Thank God for it, man. So, okay, so we got your program, and let's see, that's 2, 3, 0, 1, output 1, 2 and 3. Let's see, 3 and 6, 2 and 3. That looks good. Okay, so how do I download?
Communications. Full active. Ethernet. Click on the processor. Download.
Yeah, anytime you download to a real PLC, I always make sure that that nobody's got their hands in the machine when you do it. I've never seen a PLC actually cause a reaction, a movement on download, but they there's a warning that it make it happen, you know. I tell you what I have seen happen. It was super dangerous before, and I won't elaborate on it too long. But there was a engineer from up north that wrote some programming for a machine that we had, a new machine that we got in, and he was using a lot of latch instructions. You're getting ready to get into latch instructions. To those of you that are caught up, he wrote latch instructions for the cylinders, for the solenoids that run the welding guns on this machine. The guns that came out, cylinders that went out and did welding, automatic welding. And in his logic, there was a glitch in there to where whenever you hit the E-stop and then you cut the machine back on, his latch instructions for the guns were staying on. He didn't unlatch them when you hit the E-stop. He didn't have logic written to unlatch them. So here's what happened, man. We were about flipping out when we saw this happen. This brand new machine come in. We would cut the power off and we cut it back on. Whatever welding guns that were extended at the time that the E-stop got hit, when you cut the power back on, them welding guns, bam, they went right out instantly before you could. I mean, it was like instant. I said, my gosh, what is this going on? The welding guns are coming out, bam, instantly as soon as you cut the power back on. And so we called the guy and told him what was going on. And he said, oh, I know what it is. And he said, I got to write some logic to go in there and unlatch everything whenever you kill the power. So that was a dangerous situation, man. If somebody had their hand in that machine, man, it would have broke somebody's arms, man. With them welding guns going in like that. And it could have easily been one of us. With our hands in there changing electrodes and doing changeovers, somebody could have really got messed up bad. And so make sure nobody's doing anything with their hands when you're downloading or even powering the machine up, for that matter, like we were doing when somebody powers something up. Don't let an operator be in there, because somebody could really get hurt or get killed, you know. So okay, so here goes your switch. So we go hand is good, and your light, and then auto's good. Back to hand, we do start. Perfect. Can you see it, Victor?
Yeah, I'm seeing it.
All right, good. And then we go stop. And we go now auto. And now here goes the float. Down, up. Perfect. Perfect. Wonderful. That was very good. Okay. So that's a 100 on the real one. I'll start updating grades tomorrow. And so all these labs that we're doing, and I'm grading them on the fly like this, that stuff will be put in the Moodle. I'll start working on that tomorrow, and then grading the assignments that you're doing, those written assignments. And there are several in there. You have you check I've added several things today in Moodle as far as assignments. So take a look at every single one of them instead of me trying to tell everybody what they hadn't done. Go through every one of them and look at them and see, have you done them. Section 2, I'm putting things in section 2 now, to where most things are in section 1. I put some new stuff in section 2, and I'll be putting stuff in there pretty much for every session. I'll be adding things to it because we've only got like till July the 8th for this class. So this month is already, we're sitting here at June the 4th, so we've got, you know, a little over a month, you know, a week and a half or so to go. A month and half of a week. So, you know, anyway. Okay, so that's good. And who?
Me.
Okay, Roger or?
Yeah.
Okay, Roger. Okay. So let's go here. And go here. And Roger. And Sump Pump, Roger. Good. I tell you what, I like Zoom a whole lot better than Blue Button. Y'all remember Blue Button from last semester?
Yeah.
This is a lot better than Blue Button, ain't it?
Mm-hmm.
the
From what I
videos.
heard, cheaper.
Huh?
I said, from what I heard, cheaper.
Really? Yeah. They talk like the Blue Button Company, boy. They tried to sock it to the college, man. I know I was recording. I mean, I'm doing full length recordings of all the sessions, and so I'm probably at the top of the list on using up data with this company. I don't know what it's costing, but they talk like they hung a real big bill. They tried to charge the school a fortune because there were so many of us using it and recording and all. But you know, okay. So how do we down? Let's see. Let's got 2 and 3. I'm checking your addresses. Everything's fine. So how do we download?
Go to communications.
Okay.
Who active?
Okay.
ABV or no, it's Ethernet. Yeah. Now you go down, click that 130, 130, 130.
Yep.
Download.
Okay.
I was sitting there thinking about the virtual one.
Yep.
Download. Download.
Yep.
Now I hit cancel and do it all over again.
No, getting too late for that. Okay, so that's our switch for hand, and all those good. So back to hand, we're going to start, let go, perfect, stop, perfect, automatic, and here goes the float, up and down. Water's coming in, water's pumping down, going way down, bam, we cut it off. So that's good, very good. Now, float switches can be used in waste treatment. They can be used in hydraulic units for keeping up that if you're too low in the fluid in a hydraulic unit for a hydraulic press or something, that there'll be floats inside a lot of them to where if you have a hydraulic line to break and you lose a lot of fluid in the system, that float will drop and it won't let the hydraulic pump come on because you're low in fluid. So these floats I'm wagging here in the screen, they're used on hydraulics. They're used in wastewater. They're used in brine tanks like where you are, Victor and McGill. You probably got a float, maybe have a float in a brine tank for salt water for your processing your meat.
Yeah, I got a RO system for a water jet. The RO tank got one of them.
Okay, for like plain water.
Yeah, treating water to cut parts of the belly like a water jet. It has to be clean.
They're using water to cut the meat.
Yeah.
Okay. Boy, I bet that's a wet area.
Not really. Just pressurized water. The water jet's up to 60,000 psi of pressure.
Lord have mercy.
Yeah.
Whew, man.
Yeah, I've seen videos of those things, and they talk like they can go through the base of it and start drilling into the floor if they stay in one spot too long.
Yeah.
Okay, I got Roger recorded there for the real one, and let's see who else we may have. Let me take a look at what we're actually missing, what I don't have checked off, and for who's in the session right now. Let's see. See, there's several people have had to drop and have had to get out of the session. Let's see who's here. We have let's see. I saw Benjamin there. So let's see, Eric's got everything. Justin Sokolowski's got everything. Kenneth McKelvin, he's got everything. Roger has got everything. Victor has got everything. Okay. So everybody that's in here has got everything done as far as labs. The next one is going to be a latch and unlatch lab. So I'm going to let you tell me. It's 9:30, but I will say this. Let me get my camera down here. Okay. It's 9:30, but I'm going to give you this option because I'm fine with doing this if anybody's interested. Does anybody in the, let's see, I see Jamie. Let's check Jamie here. We'll see how much Jamie's got all his lab stuff too. That's good. Does anybody want me to sort of explain, to give you a little information on the latching unlatched lab? Would you want me to do that now or just hold off until Tuesday? That's totally up to you.
I'd like for you to go ahead and do it. I've been playing with it a little bit. I got it running in the emulator.
Okay, all right. I'll be glad to. So again, if you're interested, you stick around and we'll go through that, what that means, and how it relates to a real latching relay. I've got a real latching relay I brought home today, and I'll show you. Once you see the real physical one, then you're going to know what's going on with the software, why they even do that. So, okay. So let me grab that big relay over that I brought home. Hold on 1 second.
Is Durwood continuing with the session, or is something going on?
He said he was going to talk about the latch and unlatch for a little bit.
Okay. Well, I gotta go ahead and get to bed because I gotta get up in the morning. My back hurts. So
Yeah, he said anybody that wanted to go ahead and go is fine.
y'all have a good night. See ya.
You too.
Okay, I'm back. So, I've got a relay here, and it's a big relay. It's called a latching relay. Do y'all see?
Yeah.
Yes, sir.
Let's go here. It's an Allen Bradley Bulletin 700 type PL mechanical. You see, it says mechanical latch unit on the front. Can y'all read that?
Yeah, mechanical latch unit.
Mechanical latch unit. So what it has here is, now if I flip this way, it's got two coils in there. This is weird with the camera like this. It's kind of backwards from what I'm trying to do. Let's go back. Now over here, it's actually over here. like that. Now, it has a latch coil and a UL, an unlatched coil. This is so crazy trying to do this in the camera, man. I feel so like I'm drunk or something. But you see a latch coil L and a UL. Now, the latch coil is on the front. It's on the front of this thing. So if you energize, let's see, let's get this wire and that wire down there. Let's get it where you can see. Those two wires are for latch. That's the front unit. That's the latching unit. So when you power that up, you put 120 volts on there. The contactor pulls in, and it actually mechanically locks on like a door lock. And when you cut power off, when you de-energize that coil that says L and there's no power on the unit at all, that latch unit actually stays mechanically locked in, or electromechanically stays locked in. Even when the power goes out, the armature inside of here, it stays in. It doesn't go back. It just stays energized in. And then, so they use these on things like what they're popular for is for bay lights, like in shops, or in plants, for instance. If you go in a plant or in our shop at the school, there's a latching relay. It's not an Allen Bradley, but it's made by Siemens. And so there's a latching relay that runs 2 rows of bay lights in the shop. And then there's another latching relay on the other side of the shop that runs the other 2 rows. And the reason why they're doing it is because those bulbs are probably around 300 or 400 watts a piece, and you put a bunch of them in there, it's too much current for an average light switch. So you can't run a regular light switch and have that many lights on one light switch. But you can have a light switch to run the coils on a large contactor, on a lighting contactor like this, for instance. And it's got some really heavy contacts that can pull a lot of amps, through. So they use them on lights, and they may use them on pump systems too, because pump systems, I worked way back in 88 and 89 at a plant that had a bunch of latching relays and all in a pump transfer system. And this system did not have a PLC, and it had a lot of latching relays in there, so that when the operator had chosen to get a batch of a product pumped from a holding tank over to a machine for molding, we had molding machines, and they would call up a certain recipe we made paper cones for car audio speakers. So we had a liquid pulp mixture, different recipes of liquid pulp with paper fibers in it and different chemicals and all. And depending on what type of a paper product you were making, or speaker cone for the speakers that we made for Jensen and Bose and Panasonic, it was a different recipe of pulp material. So they would pump it over from a holding tank to the molding machine. Well, while it was transferring, if the power went out, that was the issue. You didn't want the system losing memory where it was at. Well, so it wouldn't lose memory because everything, they had to hold the whole process on latching relays and timers. Again, this was before PLCs, before they transferred over to the PLC system. And after I left, they did that. And then the functionality of this latch unlatch is replaced by PLC instructions that are inside of a PLC that does the same thing as this does. So here on the front, you have a latch coil. On the back is an unlatched coil back here. So you see those 2 wires there? That's actually the unlatch, or the UL that's shown right here that says UL. So here it's latch and unlatch. And anyway, so it's a really big relay there with that mechanical latch unit on the front of it. So we're going to look at how do you do this? How do you do this in a PLC? And with the PLC, it remembers that you had it on even when the power goes out. As long as the battery is good inside the PLC, the lithium battery that they have in them, that most of them have, then you're good to go. The latch instructions are supported by a battery, by the lithium battery that's used in them. Okay. So now, so we go to share screen, and I want to pull up the guide, the lab guide Let's go to, hold on. Let me find my Moodle page. I'm going to show you first. Okay, I can't do that. Let's go here. Let's go there. Okay, that ain't gonna work. I've got to get back to my Moodle page. Maybe there. Yep. Okay. Okay, so do y'all see? Well, it says it's timed out. Good gosh, why has it done that?
Hey, Durwood, you're gonna go back over this Tuesday night, right?
Yep.
All right. Well, I'm gonna get going then. I'll see you.
Okay. Okay, that's fine. This is only optional to do it now for anybody that really wants to get into it. It's fine if you have to cut out. Let's see. I've got to log back into the main page because my single sign-on is not the same in Moodle now. If you go straight into Moodle, it doesn't keep up with single sign-on. But if you go in through the college, then you can use that single password. And I don't remember the older password I had. Login failed. Good gosh, come on now. Let's go back. I got to go fresh into the school website again to even get in back into my Moodle again. This is kind of weird. It didn't bump me out of the session, but it won't let me get back to my regular Moodle screen for some reason. And there may be a way of doing it, but I hadn't seen how once it times out.
I think they added that timeout as a security feature. So like if you got up and walked away from a computer out in public, somebody couldn't sit down behind you and have access to all your stuff.
Okay. Well, that's a good idea. Okay, let's go here. All right, now, so do y'all see the welcome mat?
Yes, sir.
You do? Okay. So when you get down here into section 2, the lab guide for Latch and Unlatch. And where's my percent right here? They're talking about the hardwired relay that I just showed you. If you were going to do that relay I just showed you, then it would take 2 momentary buttons. I normally open here and I normally open. Do y'all see me? My mouse moving over those push buttons now?
No, I still see your Moodle page.
Yeah. Okay. Stop share. There. How about now?
Yeah, see it now.
So for a real world latching relay, you got a latch coil and an unlatched coil, 2 separate coils. And it takes a momentary pulse here on PB1 to latch that coil in, and it's going to mechanically stay latched in. It's going to cause the contact over here to mechanically latch, even when you let off of the push button. So for latching coils, you don't want to have a maintain contact, or you don't have to have a maintain contact. You can do momentary like this. And so that's what we're going to do. It'll be a momentary here normally open and another normally open here. So go ahead.
So Mr. Durwood, the latch and the unlatch, they're internal, right? They're based in the program.
Right. Yeah. The reason why I'm explaining the mechanical one, the electromechanical one is to where this came from.
Okay. Yeah.
You want to know where did all this
Yeah.
come from, and it came from that that double-decker relay that I just showed you.
Yeah. Yeah.
So this schematic is what it would be if it was like in our shop, for instance, or somewhere where there's no PLC involved. So you can have, for instance, you could have two buttons like this normally open, and let one of them pulse at latch and the other one actually unlatch. Because once you latch it on, it's going to stay on forever. That contact, when it comes on down there, it's going to stay on forever. Even when the power goes out, when the power comes back on, it's going to still be on. And the only way you ever cut it off is to pulse, give an impulse to the unlatch coil, give it a momentary push, and it'll unlatch. It'll unlatch it. The mechanical part of that mechanical unit I showed you that said mechanical unit on the front, it's just like a key switch whenever you latch it. So that's the way it would be in a physical one, you know.
So if I'm understanding it, you could use a push button, say, to start a water pump where you wanted to water some crops. And then you could set a timer in between that push button and have that timer give a pulse at a certain time to unlatch that power going to the pump.
That's right.
Okay. I understand that pretty good.
That's right. Exactly. That's the way you could use it. And if you did it that way, then as soon as you give the first impulse for the pump to come on for irrigation, whatever you're doing, then if the power went out and come back on, that system would resume right where it was at. You wouldn't have to go back out and cut it back on.
Okay, so it would still keep track of how much time it has put liquid out, and then at the end of that timer set, it would send another pulse to cut it off. If I was to use a timer instead of a second push button. Right.
Yeah, and I'll show you. I'm gonna show you real quick while you're talking about this what timer you would use. So I'm gonna switch screens right here and show you. There's a special timer called an RTO timer that you would use in that case, that it would actually remember the time once you hesitate it and then start back again.
Okay. Because I know with a lot of the lagoons, they have to keep track of how much liquid they spray on the fields or for how long they let it run.
Right. Okay. So I'm going to switch screens here. So let's go back to the Logix screen here. Now, if you were going to, okay, do you see my the studio screen now?
I do.
So let's say, for instance, that you were going to use a timer. Now, you go up in this toolbar, you see my mouse moving around?
Yes, sir.
Now, you've been using like some common symbols up here that are under favorites, or they might be under bit, okay?
Okay.
Hold on. Why is it not responding here? Because I'm online. Let me go offline. Now, do you see me clicking there now?
Yes, sir. You're on bit.
So under bit, you've got these instructions here. Under timer counter, you have 3 timers. That's timer on delay, timer off delay, and retentive timer on delay. So a retentive timer, what it does is just an on delay timer, like TON. It's an on delay timer. When you put power on the timer, it will count up to a preset that you give it, and when the preset gets reached, then it's going to energize an output. Okay. Or let's say if you want to time how long something is running, it can be done with this timer here. As far as we can get into the logistics of how that will be used for what you're talking about, but that one there remembers the accumulated time, even if it gets interrupted.
Okay.
The accumulated value doesn't go away if the power goes out. So where it says ACCUM accumulated at the bottom there.
Yes, sir.
Then that's actually going to be supported by the lithium battery in the PLC. So RTO timer is like a latch instruction as far as it being supported by, it's actually retentive. So that timer and then a latch instruction are both retentive, there where as long as the PLC's got a good lithium battery in it, then those 2 instructions will be backed. Well, they'll be supported by the battery. Okay.
Okay.
So you would use the RTO on that spray field, like what you're saying. You'd have to use that, you know. And you could also use a latch instruction. You could come up with some logic between both of those to do what you wanted to do, you know.
Okay.
Yeah. Yeah. Okay. So let's go back to the lab. Okay. So just in a nutshell, this explains the physical part of it. Now, when you go to do it in a program, then it's going to look like this. PB1 and PB2, both of them normally open or examine on. And then in your program, you're going to have a latch instruction and a L and a U. But the B300, that was in the 500 software. That was a binary bit file that you had to use it with 500 software. Yours is not going to say that at all. Yours is going to say, if for the emulator, it's just going to be, you can just give it some name up there for the latch, like for pump or whatever you want to call it. And when you do the real one, it's not going to say B300. It's going to say a real output. Like you'll use output. Let's see. Output one for the motor starter, you know. And then for your green and red lights, you know, whatever addresses they are, you know, you'll use those. So, but for the latch instruction, whatever address that you have in there, if it's local slot 2 output 1 for motor starter 1, then you would also use that same address over here to turn the green light on, and then use the examine off version of it, of the same address over here to turn the red light on and to alternate between green and red lights like that. So does that make sense?
Yes, sir.
Okay. So for PB1, you would use in your program, it would be input 1 for the start button. Now, this extra normally open push button is going to be a new address of input 7.
Okay.
And it'll be the 2 green push buttons I have out here on my control box. And then for your output, for latch output, you can let it be motor starter 1, which would be output slot 2, output 1, and then you know what the lights are, the addresses are for those. They're on that drawing. It says, you know, your green.
All right. So you said my B30 is going to be which output?
It'll be output slot 2, output 1 for motor starter 1.
Okay.
And let that run the starter, you know. And the address, look, the address for latch and unlatch, those addresses have to match. They have to match. So you got to put the local slot 2 output 1. It's got to be here and it's got to be here, because you're latching the same address and unlatching the same address. So you got to use the same address in both latch and unlatch. And when you give it a pulse, on PB1, it latches it. You'll see both of them light up, and then when you pulse it on PB2, then they'll both actually will go out. So
you want your output on 1?
Yeah, output 1, and then the lights, you know what they are. Like the green light is output 4, and the red light is output 6 in slot 2. And you just have.
Well, I got it wrote with the addresses.
Okay.
I got it as well, if you want to see it.
Okay. So let me minimize this, and
I got it wrote both ways. I got it wrote for the emulator and for the actual PLC.
Okay. I've got my screen share off. You can go ahead and do a screen share if you want to.
All right, hold on 1 second. Let me open it up. All right.
You know, you toggle that off. Now you see the strange thing is that over there on the right, your latch instruction is energized, isn't it?
Yes, sir.
And listen, the reason why the L and the U are lit up over there on the right, if you see that, that's not a glitch. The L and the U light up, and the reason why is because they use the same address. And when the address is actually latched, both of the instructions light up. I don't particularly like that, but that's the way it's always been. I mean, a lot of years ago when I was in a plant, the first time I saw that in a powder coating system, there was something going wrong. One of the stops on the conveyor wasn't releasing carriers, and I saw a latch and an unlatch on at the same time, and it was the first time I ever seen one in a program, honestly, and it was a lot of years ago, and I thought there was a glitch in the program, but then I found out that when the latch comes on, the L and the U light up at the same time, and whenever you unlatch it, then both the L and the U are not lit anymore, so they always both lit or not lit.
Okay.
And it's because that they run off of the same bit. They're connected to the same bit, so the light, whether if they're lit up or not, is indicating whether the bit is a 1 or not.
Okay.
Okay, and so if you now pulse that 2 again, right, and you saw your red light toggle on that time.
Yes, sir.
So it's working right. That's exactly right. Yeah, it is. Okay.
Thank you.
Oh yeah, thank you. Let me go ahead and record it. I'll send you on the emulator. Yep. Okay. Because if I don't, let's see. So that's your emulator latch. That's good. Okay. And then, so you've already got one written with the addresses too?
Yes, sir. You want me to send it to you?
Yeah, you can do that. I don't have the push button wired. I mean, I can go ahead and wire it. And
well, you want me to rewrite it for the float switch, and you can use the float switch like it's a push button?
You can. You could do that. You could use it as an unlatch and not even have to wire nothing else up at the moment. You know, if you want to see it run, we could do that. We could do that. Yeah.
All right. Give me 1 second to change it real quick.
Yeah, you could do that. Yeah, I was going to go ahead and wire that button in today because I knew we were going to end up using it, and I just forgot. I forgot to wire it in. I mean, it was, you know.
Do you want to see my Mr. Durwood?
Yeah, go ahead.
I got a lot of stuff going on in the morning.
Yeah, let's see it. Yeah. Mm-hmm. Is it time to go?
Wide open in the morning, Mr. Durwood.
How much?
I'm wide open in the mornings.
Yeah. Okay, that's the real one.
Yeah.
You got input 1, input 7, and that's exactly right. And then you've got output 1. When it's on, you get the green light, and when it's not on, you get that's it. That's it. So you can send it to me. You can email it to me, and then say Tuesday we'll test it.
All right. Do you want to see the emulator?
If you want to, yeah, that'd be fine. Yeah.
Hold on.
Yeah, you guys are doing good, man. Proud of you.
It was data 6 was the address for the float switch.
Yeah. Oh yeah. And like you say, it'll be fine because it's a normally open input. It's fine, you know. Yeah.
All right. I think I got it done.
I wish the class could go on longer than what it is as far as the number of weeks, because the way that the class got offered the way it is right now with the shorter hours and the shorter weeks the way it is because they told me I had to give y'all a lot of stuff to do outside the class, and that's making up for like a lot of class time is counting on you doing stuff on your own, like worksheets and reading chapters and all. I regret that I can't really go through and explain a lot of stuff in the book. There's just not time to explain a lot of it. I'm going to hit some high spots on some things.
I mean, you didn't have to stay after class today to help us. I really appreciate it because
Oh yeah,
I love logic, and
that's good.
you know, this has kind of ignited a new. I've been jumping into stuff here lately and trying to learn as much as I could
That's
with the
good.
material you're giving us, and then
Yeah.
finding a little bit of stuff online.
That's good. That's good. And you said you took a 3-day class with Rockwell a while back, didn't you? A free one?
It's been a long time ago. It's probably been about a year and a half ago, and it was just offered online for free. It was only a little 3-day. I think it was 3 hours a day. It wasn't much of a class, but it did give me a lot of the basics.
Uh-huh. Did they get into any of what we're doing now, or?
It didn't get half as deep. It pretty much went over how the input-output system works altogether. That's pretty much all it was addressing, and you give this address to this input and this address to this output, and you tell this address what to do with this address.
Right, okay.
And
Yeah.
that's pretty much the extent of what they told us.
Yeah. Well, I can tell you right now what I've tried to do with this class is I've been to Rockwell. I've been to 4 schools with there. I took 3 levels in this software, 3 levels of this software, and I've tried to take what I've learned, the best of what I've learned, and give it to you, and put the hands on with it, and I've tried to make it as good as I could possibly make it, you know, and I've tried to improve anywhere
Well, I mean,
that
I would have never. I'm sorry. I'd have never got this deep into it if Mr. McKee hadn't have recommended the class to you.
Yeah.
I mean, to me, and I started looking stuff up online and learning a little bit about it, and I really like it, and I see where it's going to be useful in the industry. So
Oh,
I
man.
might as well learn it.
Everything, 99% of what's in the industry is running on these things. I can just tell you that. You got some small machines that ain't using PLCs, they're using hardwired controls, regular relays and timers that are physical, but most of what's in the plants are PLC run now, most of it. And
I mean, I've learned so far that the beauty of PLCs is their redundancy. There's so much fault protection with eliminating all that hardware and making it
right
in the software.
Yeah, there is. Yeah.
All right, I hit send on that program.
Okay, all right. Now, Victor, you said something a while ago. You still with us?
Can you see it?
Hold on. Is that Victor's program?
Yeah.
Okay, I see the emulator. Yeah. So you just do your toggle PB2 off. Because you don't want, they'll lock up if you try to do them at the same time. Now go ahead and do your PB1 again. Okay, I see that. That's good. And now toggle that off. Now toggle the other one on. Perfect. And then toggle that off. That's it. Perfect. Let me write you down for that one, Victor.
All right.
That's good. Yeah, and your addresses look good. I'll have that other push button wired up for for Tuesday. I'll have it wired. It'll be address 7. And that's good. So you get some good rest, man.
Yeah, I need to. I had a lot of fun this morning, though. You would have enjoyed it.
Really?
Yeah, I messed around with a blaze stop. It was in bad shape. There was 2 problems with it: the rectifier for the brake and safety relay. I was getting all my safety inputs to the safety relay controller itself, but it wouldn't give me an output. So that gave it away that it was the safety relay.
Yeah.
And once I got that fixed, the rectifier for the brake, it didn't want to release the brake on it. So that gave it away quick too.
So the rectifier, do you have like a bridge rectifier pack to go on there, or what is it?
No, it's a Northern rectifier for a brake, for a motor brake.
So it's a DC brake.
The AC.
It's an AC brake.
Hold on. Yeah.
Well, a
I saw
rectifier.
The input on it was, I can't remember the voltage, Mr. Durwood. Be honest with you.
Well, a rectifier, what it does, it takes AC and it converts it into pulsating DC.
Okay.
So
Must have been DC. Yeah.
well, if you're feeding it with AC, but then it rectifies it.
Yeah.
And it takes
My bad.
it takes a sine wave, and it takes the bottom half of the sine wave and flips it up. So instead of you having a positive pulse and then a negative pulse, you've got two positive pulses. So basically, if a sine wave is like this, and you have a positive half cycle and a negative half cycle like this, the positive and the negative peak on a sine wave, it takes the negative and flips it up, so that you have two positive pulses there. It goes positive, positive, and there's no negative. So it's called pulsating DC.
I'll send you the picture of it. I mean, we ordered one. We had one in stock, but I'll send you the picture so you can look at it.
Do you have a schematic that shows the schematic of the rectifier circuit?
That's where I want to look at it. Yeah.
Right. It's probably going to look like a diamond shape with 4 diodes in there, 4 diodes in a bridge rectifier pack. And you put AC in the top and bottom part of the diamond, and then the left and the right part of the diamond would be the DC out. It would be a plus and minus DC out, and you feed AC in the top and bottom, and then the left and right legs of the rectifier would give you positive DC pulses from an AC alternating sine wave. Yeah.
I'll send you a picture tomorrow.
Okay.
No, I really have to go because I got to get up early tomorrow.
I understand. You better be safe and get some rest, man.
All right, man. I'll see you.
Okay. You have a blessed evening.
All right.
Okay. So, Kenneth. Now so I got to get the email open.
Now you don't have to stay up on my account, Mr. Durwood. I can always wait.
No, we'll go.
I
don't see it work. I mean, it's up to you.
I'm fine with staying. I love to learn.
I was just saying, I'm gonna let you tell me if you want to see it run. Now we'll run it.
Well, let's see it.
Yeah. I've been in plants, and I'd be working to 1, 2, 3 in the morning, whatever. I mean, it's kind of in my bloodstream, man, and you can't hardly get it out of it.
I did it for a little while.
And what I see, to me, if you want to do it now, then that's gonna. I just know that July the 8th ain't gonna budge, and when we get there, that's gonna be it. And so you're smart by doing what you're doing now, and every stride you're making right now is gonna make it to where you're gonna get everything. You're gonna get your money's worth out of this class, you know. And you're gonna learn. You're gonna get the most out of this class, to where some people. I saw one person pop in and pop out that really is super behind, that hasn't turned anything in, nothing. And I thought they were going to come in and do something, but I guess I don't know what happened. But it's discouraging. Yeah.
After this semester, I'm 2 classes short of my associate's degree. So I'm ready to get it done and figure out where to go next.
So are they like core classes you got to have?
No, I think most of it's electives. I'm taking 3 this semester, so that'll knock out most of it, and then I'll have 2 classes next semester. And I think they may be core because they were only offered in fall, so they may be core classes. But I'm gonna talk and see if I can't pick up a 3rd class just because I'm already there. I may as well. I'm gonna try to take one more of yours.
We've got basic electricity that's going to go from 12 to 2. I mean, it's intro to electricity. Intro to electricity. That takes you from the ground level of learning about what is voltage, what does it mean when we say voltage? It's electrical pressure. It talks about current. What is current? It's the flow rate of electrical charge per second. Resistance, what is that? Well, it's anything that opposes current flow, that slows it down, or hinders current flow, that restricts it. We talk about wattage, and it's a really good theory class that everybody needs to have to understand electricity, period. And we get into Ohm's law formulas, calculating, if I give you a circuit with so many volts and so much resistance in the circuit of a load, how many amps does it draw? And you use Ohm's law to calculate amps, or solve for resistance, or volts, or solve for wattage. And you get into series circuits, parallel, combination circuits. It's all the very ground floor fundamental stuff that everybody really needs to have if they're going to be a good electrical technician, control technician.
We learned a little bit about it when we did hardware repair. I did a computer hardware software repair class, and we touched on electrical just a little bit, but it wasn't enough for me to gain enough knowledge to be comfortable with it.
Right. That's one that really everybody's supposed to have in the beginning. It's a good one to have. You really need it. And then the residential wiring class is going to be at night from 6 to 10, 2 nights a week. So both of them are 2 days a week. And one of them will go 12 to 2, and the other one goes 6 to 10.
Okay.
And so the residential has got a super bunch of hands-on. It's every circuit you can think of in a house. You can ask anybody that's took it. It's a real winner. Everybody likes it. You get done with it, you can wire anything you want to in a house. From the panel, all your receptacles, any kind of a light switching circuit, GFCIs, arc fault breakers, exhaust fans, ceiling fans, 2-location 3-way switching, 3-location 4-way switching, you name it, anything.
I tell you, Mr. King, I'd like to get behind you and just follow you around for a couple of days and just I love to soak it up, and I like people who are willing and eager to teach it to me. I love it.
Oh yeah, that's good. Well, maybe I don't know if it's possible, but if you can get both classes, man, it's going to be a booster and a half for you if you can get both of them, if you can.
I don't know if they'll let me add 2 extra. I know I just looked. One of mine next semester is a core class, so I have to take it. It's my last core class, and then the other one is I think is an elective.
Well, what you could do is this. I'll just tell you this. The class you're taking right now is 1 class out of 4 that you can take to get an electrical certificate. So you could keep in mind to go for eventually get all 4 and get your electrical certificate. That would go good.
Would they let me keep going though after I finish my associate degree? Would I be able to keep taking classes?
Yes, sir. You can do it. You can do it as getting a certificate. Yeah. If you tell them.
Okay.
You tell the registrar, you tell Billy Joe Pittman, tell her that you want to have your name registered for the electrical certificate program, and it's only 4 classes, and they'll put your name in there, and you can just come part-time to get that certificate,
Okay.
And you wouldn't even.
Yeah, because I mean, with technology and as much as you have to be hands-on with servers and stuff like that, it really does go hand in hand with what I'm going to do.
Oh, I know it does.
I've seen it more and more as I've done this class and learned in other classes. I love it. I just, it seems to me, it's very straightforward. I'm a logical thinker, and I like, flows and waves and patterns. And I see those flows and waves and patterns in the diagrams and in the way it's written, and I love it.
This stuff is super logical, man. It is logical. It's logical as you can get.
It's straightforward. Those
once
patterns can't.
Yeah. It's just like the laws of gravity or anything else. It's stuff that's just set. It's got a definite pattern to it, and once you learn how the different patterns you can use, and then a whole bunch of instructions that you can use, which you're getting ready to see with timers, you're learning about latch. Once you get into timers and the counters and compare instructions, your view of all this stuff is just going to expand like a universe. You're going to say, oh my gosh. And what it's going to lead you to realize is, I tell people that 99% of what you could imagine for a machine to do, I'd say 99% of it you can really make it happen with a PLC. You really can. they can accept a signal, any kind of signal you can imagine of voltage levels and type, analog or digital, or sensor wise, pressure, flow, temperature, remote signals from way off somewhere through Ethernet. It's the ultimate interface translator type control that can do almost anything you can imagine. You could do it with these things, and they got a module that'll let you connect to whatever you want to connect to, basically whatever kind of signal you could think of that you want to interface with. There'd be a module you could put in that rack up there and make it be. I think of it as being like that processor can be like a person that can speak, say, 20 languages, or more.
Yeah.
If they say there's some people can speak a pile of languages, and that processor is like that. It really is like that. When you get the right modules in there, you've got the ultimate translator controller there that can do. It's unreal. It's just unreal. It really is. It's amazing. So, okay. So this is your program, and we're going to download. So I'm going to let you
I
tell
can't
me.
see anything but your email.
I'm sorry. I keep forgetting I got to go select a particular screen out of a lot of things I've got open. And when I do that, then you got it now?
Yep, I see it now.
Okay, so now we need to download now.
All right. Communications.
Okay.
You got the Who Active and Ethernet 1. And select your controller and download it.
Yeah. But that firmware update that you see there, that's a feature that we're going to go over at some point. I hope I can remember to do it at the right time. The firmware, basically, for you to update firmware in the controller is this. It's like going from Windows 7 to Windows 10, or going up to update your operating system.
Okay.
So the operating system in the PLC is something we hadn't looked at, and it's called the firmware, and it's got, like, that PLC's got revision 32 firmware in it. Well, I've got a PLC, another one here at the house. It's the older one's got revision 19, and I'm getting ready to upgrade it, and I can't go any higher than 20 with it because of the type of PLC it is.
Okay.
But when I go to 20 with it, it'll let me then I can use my Windows 10 laptop with that older controller. If I can go at one version, it'll get me into a rev level that I can use with a Windows 10 computer with that PLC. So anyway, so the rev levels go up every so often. Every time they come up, every time they upgrade the software, they'll come up with another firmware revision that you would have to upgrade in your controller if the controller can accept that version. And there's a compatibility page with Rockwell that you can find out what model number PLCs, how high they can go in firmware and things like that. So, but it's like going from Windows 7 to Windows 10 or so on. It's operating system.
That makes sense.
And your software in the laptop has got to be the same exact rev level as the firmware in the controller. That's kind of what they are. It's not backwards compatible. With Rockwell, the 500 software is backwards compatible. So if I had the newest version of 500 software, but I had a really old 500 controller with old firmware in it, then the 500 software is backwards compatible to controllers. But on Studio 5000, it is not. And that's kind of a pain in the rear, that if you're going to talk with an older controller, you got to go back online to Rockwell to their download site, and you got to download that old version and put it in your laptop and have multiple versions in there. And to talk with an older controller, like at the college, the ammonia refrigeration building that's down past the welding building, Fran Lurkey teaches ammonia refrigeration. That PLC, it's a 5000 controller, okay, but it's a version 17. So that PLC has been there for years, and the firmware is 17. Well, I had to download 17. I've got it. Now I've got it. But you can't run 17 on a Windows 10. You got to have a Windows 7 machine. So my other laptop, that I've got put to the side now, it's got version 17 on it. So
it's a Windows 7 laptop.
Windows 7 laptop. So if I have to go in there and help Fran with a restore a program, if he loses the program or something goes wrong and he's not able to see what it is, I'm gonna take my Windows 7 down there and hook up because I got the right version for his system on that. So.
Well, see, we're learning this semester. I'm learning about virtualization, how to virtualize desktops and things like that.
Yeah.
And that seems like a pretty good place that would work. You could virtualize Windows 7 on your Windows 10 computer, run that software inside that virtualized version of Windows 7, and send it out that Windows 10 physical ports. So you could still use the Ethernet and the USB from a Windows 10 machine, but you would actually be running it inside of Windows 7.
Well, you know what? We did that. We spent about 2 days doing that. Let me just tell you the problem I had. You might have the answer because we never found out how to make it work. I've got the what's it called? Hold on a second. Let me minimize you. Let me just tell you while I'm I've got VM Workstation up here. Hold on.
Is it VMware Workstation Pro?
Hold on a second. I can't go to get back out. Share. Do you see my desktop?
I do.
I got VM Workstation right there.
Yeah, that's VMware Workstation. That's a good program for virtualization.
Now here's the problem that we had, and I got upset about this. It was okay. Angela in IT, she put me the VMware on there, okay, and then they also loaded Windows 7 inside of it, and then I downloaded from Rockwell version 17 of the 5000 software, and I downloaded also version 19. I downloaded some old versions you can't run on 10. So when I did that, I never could get the Ethernet port to work. That's where
you may have had to go through the settings. There's a configuration manager that you can go through for all the external ports, and you may have to map the port from inside the virtual machine to the actual physical port on the Windows 10 computer. So if you're drawing, it virtualizes the network connections between the Windows 7 and the Windows 10 that's running on your computer. Because that Windows 10 is always running. That Windows 7 is actually running inside of Windows 10.
Yeah.
So if you think about it being in layers, between Windows 7 and Windows 10, there's a layer where they build all your virtual switches that would connect to the internet. That's your whole networking layer. So you would have to map that network to your external network in order to send.
That's the problem that came in, is that Angela said that we cannot let a Windows 7 machine connect to the internet.
Windows 7 is not receiving updates anymore. So you could kill your actual internet connection and map that Ethernet port as an outbound, inbound only. So if you plugged in a physical wire going from your computer to the PLC, it would still talk to it.
Oh, that's what nobody could figure out. Nobody was able to help me figure that out.
I'm guessing that's how it may work. I don't know. I don't have the most experience. Mr. McKee'd be a really good one to talk to about that. He's really, really good with virtualization.
What I'll try to do, I think I'll probably shoot him an email, and
he'll probably know a fix within 30 seconds. Knowing him, he'll know a workaround or a way to get it going. Man, that's a good teacher too. He's another one like you. He stays on it 24/7. He's always there to answer questions.
Yeah.
I like learning from him.
I tell you, I had just give up on it because I called Rockwell, and Rockwell didn't even know what to do with it.
I mean, there may be no way to do it. Like I said, I'm learning it. Mr. McKee, he's pretty much a professional in it. He's got it down pat. If anybody, that's who I'd talk to about it. I mean, I have my guesses, and I could probably play with it for a little while and maybe figure it out. But he'd probably know right offhand how to do it.
For somehow or other, we were never able to get it to. I could never get an external connection from the virtual machine, and it was anyway. That's why I pretty much give up on it. I didn't ask nobody. I didn't want to worry nobody And
I'm gonna look right quick. I'm gonna pop up in a virtual machine I got installed on my computer with the same software. I'm running the same software on my computer. See, I just want to look at the settings, network adapter. Yep, right here you can bridge the network connection. And you can replicate the physical network connection state. And it should just bridge it right through from the virtual machine straight to your physical port.
Okay. Well, what we can do.
Now whenever you connected that Windows 7 or whenever you went in and changed that setting, I would recommend disconnecting the whole computer from the internet. So turn off your Wi-Fi or unplug your internet Ethernet and then change that setting. That way it doesn't try to connect to your Wi-Fi. It'll connect to your Ethernet port instead. If you leave your Wi-Fi on, when you enable that bridged connection from your Windows 7 to Windows 10, it's going to want to activate your Wi-Fi instead of that physical Ethernet connection. It's going to replicate whatever state your computer is in at that time. So if you replicate the Ethernet connection, you need to have the Wi-Fi off. If you replicate the Wi-Fi, then you can leave the Wi-Fi on, but then you won't be able to use the Ethernet behind it.
So I got to disable Wi-Fi.
Yep, just turn the power off to the Wi-Fi, plug up the Ethernet, go into the options, hardware, network adapter, and just click that bridge network connection. And then apply it, and it should work in theory. I don't know 100%. Like I said, I've never tried it myself, and I don't have the most experience.
All right, so you would go under, once I disable Wi-Fi, then you go in where now?
You would go into, let's see here. I'm gonna bring it back up right quick. Excuse me. You'd go wherever your Windows 7 virtual machine is. You'd click on that tab at the top, and you'd go down to network adapter. And then you would click under where it says network connection on the right. You would click on bridged connection, connect directly to the physical network. And then you would click replicate physical network connection state.
Replicate physical network
connection state.
Connection state.
If you want, I can do a screen share. I got it pulled up right now. It's for a different VM. It's for a different version of Windows. But it still has the same settings inside of VMware. That's where you would change the setting, not inside of the actual Windows 7 itself.
Right. Now, if I pulled it up on mine.
Yeah. Just don't tick those selections. Click on Windows 7 on the top where your tabs are.
Do you see my machine or?
I do. If you'll click on the top where it says Windows 7 x64 in that tab, go up just a little bit.
Right there?
No, over to the right and go up. There's a tab at the top where it says Home. Then right beside it says My Computer. Go down just a hair with your mouse and to the right. Right there, it says Home, My Computer, and Windows 7. Click on right there where it says Windows 7. And go down to Network Adapter and click that. Right there is where you would check it, where it says Bridge Connection Directly, but don't do it while you're on the internet because that'll connect that Windows 7 to the internet when you start up Windows 7. When you cut off your Wi-Fi, by default, it's going to look for whatever kind of connections coming in and out, and that should be your Ethernet.
Okay. That makes sense.
But that's the selection. You would do bridged, and then you would do the replicate physical network state, and it would just straight bridge it straight from your physical port on your Windows 10 to your Windows 7.
Disable Wi-Fi before you ever get into this.
Yeah, disable Wi-Fi before you select that, or you can go ahead and select that but disable Wi-Fi before you boot up that Windows 7 virtual machine. So before you click play over there or start or power on or whatever it's listed over there, before you click that, you need to cut off your Wi-Fi to your computer, which there should be a switch somewhere on the keyboard or on the computer somewhere that just cuts off your Wi-Fi.
I'm not sure if it's got a physical switch on this, and I haven't looked for it, but I know that I can hit disable Wi-Fi.
Yeah, that's all you would have to do.
In
that
properties.
That would sever your internet connection, and by default, it would start looking at that Ethernet port. If you had that Ethernet port installed and it should come by default, it should see it.
Yeah, it would be the Ethernet port that I would be setting up with like a static IP for connected with the PLC at school.
Yeah.
In the ammonia refrigeration building. Or I've actually got a small one here that's an older one I would like to practice it on. You know,
I'd like to get my hands on one and just see what I could do.
Yeah. I've got an older, and I'll show you with the webcam. I've got an older PLC that's sitting right there. You see that?
Yeah, I believe I saw it earlier when you showed it.
That little small one, that's one I had the first PLC school I went to back around 2012 or so. It's a 5,000 controller, but it's a version 19. You can't go any higher than 20 in firmware with that. It's a L35E. It's a small one. Anyway, it's the older one, and I got version 19 in there. I've got version 19 loaded in this virtual machine here on this laptop. You know, I've got the right software on this laptop within Windows 7. I put RS Logic 5000 version 19 for that controller. I put it in here. I spent, a couple of days getting everything in this virtual machine and never could make it work with anything outside. I said,
it may not work the way I told you. Like I said, that's my best guess. And from my understanding of how it works, it should work, but that doesn't mean it will. And Mr. McKee's always going to be your best bet. When it comes to anything being virtualized, that's the man to talk to.
Well, see, here's what we didn't do. I didn't click it off of host only because Angela set it on host only.
Yeah. And I don't blame her for that. I don't blame her for that because that seals your network connection from that Windows 7 inside of your Windows 10.
Yeah.
If that makes sense. You got a connection with only your Windows 10 computer, not the external network beyond that Windows 10 computer. So Windows 7 can talk to Windows 10, but that's it. That's as far as it goes.
Right. And the shared folder is actually my download folder. And they called that like the Z drive, I believe. I think that's what she called it, a Z drive. She called my download folder in 10 a Z drive for the virtual machine. And so to get any files,
a smart lady.
To get any files into 7, I got to download them into the download folder in 10, and then I can access them through the 7 machine through the Z drive, which is that's the connection point.
Yeah.
So she's looking out for security of the college and for the computer because
that's a smart lady, because if that redundancy, you need it. You need that security protocol. You need that redundancy because there are so many people out there right now that would just take any little piece of information they could get and run with it.
Yeah.
And I like the way they do things out there. Mr. McKee, he's a great security teacher. He is, and virtualization is a big part of security now, and he's teaching it right. I like the way he teaches us.
Yeah. Yeah. Okay, I think you're right there. As long as I disable Wi-Fi, that I think that sounds like it would work. It really does. And my thing was, I was thinking that what I would have to do anytime I ever had to go help Fran Lurkey was I'd have to get my other laptop and take it down there.
Well, you could always connected it with USB. USB would have worked. Ain't it got a USB connector on the PLC? It would have been slower to upload and download. But
I'm not sure. I'm not sure if it's a Control Logix. It's not a Compact Logix, and I don't remember. I don't know for sure. Compact Logix has 2 ports on them. That Control Logix, I don't know. It would just
the older ones. I thought
it would have to
have a serial.
It's got Ethernet going in, but it would have to have. It would actually have to have a serial port. it would either be a serial or a USB that would be the actual one, and it would probably be a serial port. Like I'm going to show you this one.
If it's older.
If you look right here, this has got a serial on it. You see the serial?
Yes, sir.
So back in that time range, it was a 9-pin serial or Ethernet. So more than likely on that control Logix, which is the big brother to that Compact Logix, it's a larger one. More than likely, it didn't even dawn on, but it's still, you still got to be able to get out through a port. See, with this laptop, if you're going to go serial with this laptop, then I've got to use I've got a
USB to serial.
USB to serial,
and then a serial in.
Right. Mm-hmm. So I've still got I think the bridge connection you're talking about is still the only way you're going to do it, because you've got to get out of 7 out to the physical world, you know.
Just make sure when you get done with it that you shut down Windows 7, shut down that virtual machine, and then change that setting back before you restart 7 or before you turn your Wi-Fi back on, because Windows 7 doesn't receive software updates from Microsoft anymore.
Yeah.
So you might not, you don't have the kind of security with going online with Windows 7 like you used to have. And it's just so smart not even to connect it to the internet anymore. Windows 7 is just a big old flop on the internet now.
That's what she said. They don't want nothing on campus running 7, you know.
No. It's just, it's seen its golden day, and it served its purpose, and it's still used in a legacy way. Like you said, just like you said, with supporting legacy PLCs and stuff like that, there's still a lot of call for it, but you don't need it connected to the internet. You're best to do, like you said, download through your Windows 10 and then just move it over to Windows 7.
Yeah. Mm-hmm. Yeah. But anyhow, that's I appreciate that. That's something I can keep in mind, and at the right time, try it at the right time. I'll try it here at home on this version 19 Compact Logix to see if it'll work, and I'll be real careful about it. So, okay, so now, so we can do the latch now. So I'm gonna hit the latch instruction. I did that, and it came on, and you see, let's see. Let's see. Let's go back out. And unlatches the float. I just bumped the float in an unlatch. So let's go. I'm going to hit latch over here, and you'll see it come on. Let's go back out. Latch. And then unlatch, I've got the float in my hand over here. And so that unlatched, you see that? See the float?
Yes, sir.
And the webcam. And then latch again. Now, with the latch like that, it's on. You see it on?
Yes,
now,
sir.
I'm going to cut the power off to the PLC. So I'm going to act like we got a power outage. I'm going to go up here and flip a breaker. There's a breaker right back over here. I've just flipped it. I just killed the power. So that PLC is going out now. See, it went out.
Yes, sir.
And then also on the screen, you're seeing it says it's lost communication. Can you see the screen there too?
Yeah, I see it on my other screen too.
Right. Okay. So now all we got to do, let's see, let's get that camera there mounted there where we can see. Here. I wish I had like a way of having several cameras running at the same time. I'm going to cut the breaker back on right over here by hand. So as soon as it boots up, you're going to see that light come back on. You watch closely. I'm not going to touch anything. As soon as it boots up, you'll see that green light come on by itself. I won't have to do anything. You see the push buttons over there? I'm not hitting anything. Just watch.
I see it all.
Just watch. As soon as the PLC boots up, you should see it come on. Yeah. And I haven't even reestablished communication with the laptop yet. You get some green lights up there up top, and then it's getting ready to come back on. You see it?
There you go. Yes, sir.
By itself. So that instruction, it does, it does what that big relay right there does.
That would make sense. Like during a power outage, if it had to kick over to generator power and it went a good 30, 45 seconds without power or something like that, that makes perfect sense why that would be used.
Yep. So if it's latched when the power goes off, it's latched when it comes on, and if it's unlatched when the power goes off, it's unlatched when it comes back on. And see, and the laptop is still disconnected. I mean, I got to hit OK to retry communication. Now it's not online. I got to hit online again. So now it's actually seeing it again. Now that's back connected again, but it's doing what it's supposed to be doing. I go back up here with the float and unlatch it. Bam, there it went. That was it. So that was perfect. So you got it going on, man. You're gonna make a high-end industrial programmer, man, for sure.
I don't know if I'm looking for all that. I'm just looking to learn what I can and be comfortable.
Right. Wherever you end up getting in at, though, they'll use you for sure.
I just got to get over my stubbornness of thinking I know more than I should.
Well, when you get into a plant, though, you're going to be jumping into some big water, with the controls and all. There's a lot of stuff in there. But what you're learning, as fast as you're learning, though, you could soak it up about as fast as anybody, as fast as you get exposed to it, you'll learn it.
Yes, sir. That's why I appreciate you staying on tonight. You didn't have to do that. That was really nice of you.
I'm into it, man. I am. And my whole purpose, like I'm 56 years old now. My whole thing is to see other people get it and use it. And that's my whole reward, man, is seeing people get it and use it,
Yes, sir.
Yeah.
Yeah, I believe I can go pretty far in it. And like I said, my main degree is going to be in IT, network security. Yeah. But I'm also getting a certificate for a couple other things that'll go in line with the IT. And then I'm hoping maybe to keep going and get that electrical certificate, because that would just go hand in hand with that IT.
It would.
That
it really
get me
would.
in the door pretty much anywhere I wanted to.
It really would. It would. I mean,
thing is, I've learned so much in the last 2 years. Now I'm confused on what I want to do. I've got PLCs as an option. I've got security as an option, networking as an option, business administration as an option. I mean, there's so many options with what I've learned. Yep. Now it's just kind of focusing in on one and deciding where I want to go from here.
Mm-hmm.
I'd like to get. I'm sorry. Go ahead.
You can do a blend. You can do a blend of and maybe be major in the IT department and still kind of be involved inside the plants. I know at Mount Olive Pickle over there, the lady told me, was telling the students when we went on a tour over there, she got talking about IT and all and how everything's networked in there. They got their industrial network tied to the office so that the office can monitor and it knows the production output on machines, and their office and their plant floor is all tied together. And she says everybody in maintenance doesn't know how to make those connections and bridge between the network in the plant and the office and give the office people the information they need as the machines are running. And she said when we have somebody like that, they're worth a lot, So she's got one or two over there just like that, and that's about it. So that's kind of if you got your feet in both.
I picked a really fast growing field to get into. Computers altogether, it's changing so fast all the time.
It is.
And it's a lot to keep up with just the learning. Since I've started school till now, things have already changed so much.
Yeah, it has.
And it gets kind of frustrating trying to keep up with everything that's changing, especially when you're writing a code like Python or something like that, the libraries change every other week. Your resources change every other week, and you've got to adapt to that on the fly. So research is a big part of it, is just learning on the fly. When you're into something and you're neck deep and I'm lost and confused, I'll pull out a book or I'll get some documentation from somewhere and I'll go to reading, and eventually I'll figure it out.
Mm-hmm. Yep.
Well, Mr. Durwood, I really do appreciate you staying on tonight.
Yeah, you're welcome. You're welcome. I'm happy to see you learning like you are, and it's worth it to me, because you're going to get your money's worth out of the class. That's what I want to see. I want people to be satisfied.
Yeah, I liked it. It's different. It's different to me. It's related to the field I've been in, and it was starting to get a little bit stagnant, for lack of a better word.
Mm-hmm.
I was doing the same type of things, installing virtual machines and doing a little networking and doing a little security and learning how to do this. And it got a little mundane. So I said, I want to, change it up a little bit. And then I started learning electrical, and I see the implications of the PLCs with the technology that I'm learning. The integration of those two things is going to happen. It's an inevitability that the more PLCs grow, the smarter they get, the more they're going to need networking and the ability to be managed from a distance and took care of. And, it's got to go hand in hand. It looks like something I'd really be interested in.
Yeah. A friend of mine that used to work at Sharon Harris nuclear plant, he told me that some of the people there are uneasy because they got access remotely to the control system of that nuclear power plant, so stuff like this, it's a real concern,
Yeah, it would take a very, very smart man to get into that power plant. I can bet you that. Even if it was possible, it would take somebody way beyond my knowledge.
Mm-hmm. But anyway, you take it one day at a time, and keep enjoying yourself with it, and then the right opportunities to click for you at the right time, and you'll know which
That's the biggest thing right now, is looking, because I'm so close to graduating. And as soon as I graduate, I want to kind of jump head first into learning a trade, and that being my trade. Because right now I'm not learning a trade. I'm in school and I'm learning the basis of a trade. The real learning don't really come from me until I put my hands on it or I stick my head in it. That's when I start learning something. I can read it all day long and I can hold on to that knowledge, pretty good. But until I put my hands on it and until I do it, I'm never going to hold on to it permanently. But that's one of the things I love about this class, is that emulator. I can get in there and play and change things and look at things a different way. And it don't matter how many times I mess it up, the program's going to tell me I messed it up, and I'm going to be able to fix it.
It is. It's a blessing to be able to have it. I mean, I thank God for it. It's just, emulators have been around for a long time, but I've never worked with one because I've always had a real one I can get a hold of, But I said, now I'm on, we're going to get into it. So,
I'd like to learn a lot more about the physical side of it, the actual physical wiring side. I understand from the schematics how everything's run and how everything are connected, but as far as, like you said, understanding what voltage is going where and why it's carrying that volt in that place versus carrying this voltage in this place, or that's the things I need to learn, is those small details that make up that overall picture.
In January, then if we're on campus like normal, then there'll be the ELC.
We are.
ELC 215. It's electrical maintenance for automation systems, and it's using this software on a real automation system that we got from SMC. It was a Duke Energy grant that we got that system from, but it's got a PLC network with six stations, and it's an assembly line that runs. And that class, most of that class is actually me actually planting bugs in that system and actually troubleshooting. Once you learn how to read all the electrical drawings and you understand how everything's hooked up, that's where you would learn a lot there. And but it's actual PLCs running solenoid valves, is running cylinders and grippers and vacuum tools and pick and place and
see, I see a lot of it as interchangeable with a lot of the stuff I've learned. It is. Current is current. Flow is flow. Things are going to move. Logic is logic. And all I need to learn are, like I said, those small finite details, the symbols. What does this mean? What does that mean? What does this current? It's the vocabulary of it all is where
Yep.
I'm lacking, or I
Yep.
feel like I'm lacking. I may be lacking somewhere else and be a little stubborn and not see it, but I feel like the minute details are the things that are most important. The foundation of it is what I've kind of gone a little bit beyond and never really fully retained that foundation.
You need to back up and get it. Now, the very first step would be ELC 111. That's going to be in August. It'll go from August till November 12th. And because I'm scheduled for back surgery after the 12th. And so but it'll be from 12 o'clock to 2, Tuesdays and Thursdays, 2 hours a day, 2 days a week.
And hopefully, like, I would love to get hired on somewhere that would send me back to school and or even just work with me and let me go to school for what I was working for them for. I would pay for it if I had to, but I wanna keep learning and adding to what I've got, because eventually one day, there's gonna be one class I took that's gonna save me in a situation where I might have had to spend 2 or 3 hours researching or looking something up.
Yeah.
And I see that I'm getting a little bit older, and I'm starting to see how important those small details are.
Yep. But anyway, take what you can. If you can take, this one class is, you only need 3 more to get your certificate. You can get 2 of those in the fall, and the other one will be offered in the spring, which would be motor controls. It's ELC 117, and that one will probably be, it may be an afternoon class in the spring in January. The night class would be the ELC 215, this automation class. And then, but the fourth one you need for the certificate is motor controls. It's all completely hardwired controls. There's no PLC involved, but it's all physical devices that are wired together with relays, timers, and contactors and everything, and buttons and limit switches and all. It's what is good to have before you take this class you're in now, so that it just
well, I'll look into it, and I'll have to get with my advisor, because they kind of got some say over what I take and stuff like that too. But I look forward to getting more into it if I can. If the opportunity comes up, I'm sure we're going to take another.
Sounds good.
Yes,
you
sir.
have a good evening.
night.
You too. Have a good evening and have a blessed weekend.
You too.
Bye-bye.